see if other people show up since we're not full yet.
Well, they said Sunday is going to be like kind of like easy, so it's going to be light. So.
You know, there was a Republican newspaper and a Democratic newspaper in a larger town, which they very often was. They would have the Republican and the Democrat. People just bought papers. I mean, all the important people did. The lawyer did, the bank residents did.
Andy, if we're at room capacity, can I have you close the door for me?
Close the door because the audio
That's why that question was asked.
it sometimes gets loud in the hallway.
Yeah.
Yeah, it's just the sign which I could message.
Okay.
Yeah.
I assume they put me in the corner over here because I'm so loud and they don't want
Exactly.
to interrupt with
Exactly.
other recordings.
All of them.
We're good to go?
Yeah. So it's 9:30 right now. So.
Okay.
I used to get a
Couple seconds. And
I'll bet you did. So did my
Get
dad.
started.
And I read newspapers ever since.
I just grew up reading the newspaper. I still read the newspaper. My kids said it's funny. You can read it.
This is a, bi-weekly one. And I get the same reaction.
Okay. All right. Good morning, everyone. How's everybody doing? Everyone awake? Who went to the movie last night? One person. Okay. What about Brandywine? Who went to Brandywine? Okay. Only one person. Okay. So
And I went to coffee, and I had coffee this morning, so it
Nice.
was all fine.
Awesome. Yeah, so this is the Antisocial Crowd. Thank you for joining me first thing Sunday morning. Hopefully we're all awake. You know, if you fall asleep, please try to avoid snoring. But I'm caffeinated, so we should be good. If you need caffeine after this, there is coffee in the expo hall, so go check that out. Yeah, we're going to talk about data. Who went to Mad Dog's talk yesterday? Okay, a fair number of people. Okay, cool. I listened to it in the car on the way here because I was in the expo hall all day yesterday. But I listened to it. I thought it was really cool. And we did not coordinate this, but I think a lot of the things that he talked about there really play into kind of the philosophy behind the talk. Maybe not some of the things that I'm going to talk about in this presentation, but it really kind of it's important. The whole idea of sovereignty and data sovereignty, especially, is kind of what we'll touch on here. So, who am I? Let's start there. So I'm Brian. If you didn't meet me yesterday in the expo hall, there will be plenty of time to stop by our booth, later today.
What's your booth?
It's Synapse Software. So
Okay.
I'm wearing the shirt. We have the green shirts. We're kind of over by the, like across from the raffle. So that big open space where you stand and wait for the numbers to get called out. If you're facing the raffle booth, your back is to us. We've got the photo booth, so come take your picture and talk to us about data and open source and stuff like that. Happy to chat about just about anything because I've been doing this for a long time. I've been a software engineer. I think the slides are not advancing on your side. They are on mine, but
Yeah, it says data graveyard to data garden.
so while you look at that, I'll just talk about there's a list of things. You don't need to see that. So I've been a software engineer for a long time. My background is writing code. I used to work for a company called Sharewell Software. Does that mean anything to anyone? No. Okay. Has anyone used ServiceNow?
I was just going to message.
One person has used ServiceNow. Okay. Has anyone worked with an IT help desk? Okay, a couple of people. So Sharewell was a company that built software for IT help desks. ServiceNow is the market leader in that space. I used to work for that company. They went and got themselves bought out, and then the acquiring company shut them down. And that left a hole in the industry. All these customers who were still using that platform, what do they do with their data? Obviously, they have to move off of that tool for their day-to-day operations, but with the historical data, what do they do? So that was a big question, and that kind of launched me into this area of data sovereignty and how do we get them control over their data again? Realistically, they probably should have had it for a long time, but with the push toward SaaS everything, your data is kind of your own, but not really your own, but also if it is technically yours, how do you actually get it? So we'll talk a little bit about that in the talk. Obviously, I have my own company now, Synapse Software, and this is what we do. And on the slide, which you can't see quite yet, I say I'm a data archival enthusiast. I don't know what that means, but it sounded good for the slide. So one of the things that I really, so we can get the slides back up. I like looking at databases and trying to figure out how they go together and how they're supposed to go together. Here we go. Yay! Everyone give a round of applause to our wonderful room captain team. Awesome. Thank you, guys. So I like looking at databases and figuring out how they're supposed together and kind of how the original system worked and how this data can be meaningful to people. And I'm really passionate about people being able to do what they want to with their data. For a long time, I've said things like, once you have the data, you can do anything with it. I use that a lot of times as an excuse to not write code. Write code to collect data, but then make it visible. We don't really know what we need the data for yet, but we know we need the data. And if we have the data, then we can do something with it. If we don't have the data, then, well, can't do anything with it. I do have a dog. If you were at the stroll or the social on Friday, or if you're local, you have probably met my dog, Honey. I actually do have multiple pets. Here's my board of directors. 3 cats on that side, and then Honey is keeping an eye on them, I guess. The chairman of the board, my wife, did not want to be photographed. So, okay. In your careers, who has had a system of record and then changed to a different system of record? What I mean by that is, okay, we've got some hands already. What I mean by that is you have a database that stores something important, and that is the source of truth for that thing. And then your company says, oh, we're going to change to something else, right? This is a thing that happens. This is a thing that happens probably more often than we care to admit. Be it a help desk system, an HR system, an accounting system, project management, right? Who uses Jira? Okay, half the room. That's good that it's only half the room. Sorry. This is being recorded, so I shouldn't say anything too bad about it, Atlassian. They are huge. But yeah, so churn is a reality, right? In all likelihood, we're going to switch from one system to another. In fact, I would say that churn is an inevitability. It's likely that over the course of doing business, over the course of evolution of companies, you're going to switch from one system to another, which means you're going to have to deal with this data sovereignty, data governance, data control issue at some point, whether you want to admit it or not. And I think it's important to be prepared for that and think about how you want to navigate those waters. Because there are a couple of nuances. So one system is systems stagnate and die, right? Systems get sunset, systems get acquired, and then are they being supported? Are they not being supported? We don't really know. Did the acquiring company buy the company I liked for the customer base or for the product, or because they wanted to cannibalize the product and turn it into something else in their own product? Those sorts of things. Your business hopefully outgrows systems. The system you start with is not something that it might not support additionally more complex workflows as you grow, as one department turns into 5 departments. You just need more and more complex software, and maybe the software you start out with just doesn't support where you're trying to go. Hopefully, right? In some cases, vendors outgrow the companies that they're working with. I'm going to throw GitLab under the bus. I really, really love GitLab. I've used GitLab for a long, long time. However, they are focusing on a market that is completely different from where I am as an individual, where I am as a company. I used them because they were a great self-hosted, open source Git UI, right? It's a web-based thing. I could host it myself. Fantastic. They are going into DevOps and observability and DevSecOps, all great stuff, but what they're investing in is just not, there's more to the tool now than I will ever use, and they're focusing more on that and kind of ignoring the Git side of things. So I'm not using them for my company anymore. And then, of course, the things we don't want to talk about, price, politics, all that nonsense, right? A lot of people are leaving ServiceNow right now because ServiceNow just jacked up the prices. Atlassian is going through a similar thing. And that's a thing, right? If it's outside of your budget, well, maybe now it's time to look for another tool. And, then your data gets orphaned, right? So I already asked if anyone's heard of ServiceNow. I'm going to use ServiceNow as an example because lots of people have heard of it. Not necessarily this audience, but they are the big market player in ITSM. One thing you might be doing is moving from, we'll just say ServiceNow as an example, to a local database. So that's one thing you might do with your data. You might be switching from ServiceNow to another instance of ServiceNow, or some of these systems are really, really customizable, so a lot of times companies get into trouble with over-customizing, and then they have to kind of backtrack. And one thing you don't want to do is just copy all of your old data into the new system, because then you're inheriting all the problems that you're trying to get away from, right? You might be moving from another system into ServiceNow, or you might be going from ServiceNow to another system. Basically the same. For purposes of this talk, basically the same thing. I stole this slide from a talk that I was giving to ServiceNow audience. Why might you need historical data? Lots of different reasons. If you're a company of a certain size, you have a need for historical data. It doesn't matter what industry you're in. It doesn't matter how much bigger than that certain size you are. You probably have a need to hold on to historical data. So it's not enough to move from one system to another, import a bunch of records, and then hope for the best. There are probably lawyers or auditors or shareholders who have a need to, or that require you to hold on to old records, and ideally in the format that they were originally in. So lots of different reasons there. We're just gonna blitz through that and go on to the next slide. So we'll ignore the top right corner for a second, because this is not a sales talk. That is my product. We're not going to talk about that. And this slide does not show up very well on this screen at all. I have kind of a quadrant sort of thing where we have fidelity on the y-axis, and then expected value over dollars on the x-axis. I didn't put ROI there because I didn't think ROI was the right term. I didn't think it communicated the right thing, because in a lot of cases you hope you never have to get back to the historical data, right? In which case the ROI is potentially zero. If you're paying for something and you never use the data from it, is there an ROI? But there is definitely an expected value, right? If you get audited, you need to get that data. That expected value is really, really high. So we have a few different options here. Of course, the original platform, if that's an option, the fidelity is off the chart because it is the original platform, right? But the expected value over money is abysmal because you're paying for a lot of features that you're not going to use. And then you have things like storing it in a database or a data warehouse or a data lake. I have data warehouse and data lake further along the expected value axis, because the advantage of those sorts of things is that you can correlate it with other data that you've captured from other systems, or maybe the references that you had from the system of record to the other systems you were using at the time can still be maintained. It's not just a database in isolation that's just a snapshot and congratulations, here's a database, let's stick it in the corner and let it collect dust. And then we also have BI tools. You can certainly build your own UI on top of a database that you have, but that's a lot of effort, and you have to figure out how the system was put together, which can be time-consuming, expensive. Even if you hire a consultant to do it, it can be a lot. We've worked with some companies who have done that, and they, I don't think anyone has said that was a massive success. It was more a thing that they had to do, and they, they signed the check, and it was like, let's just do this, get it over with. This is painful, but we have no other option.
And you were talking with them, so they eventually came to you anyway.
Potentially, yes. Yeah, so I'm here to say there is another option. I'm not just saying that my product is the other option, because I want to talk about the philosophy, why I built the product the way I built the product. And it really does come down to these two axes. This is an open source and free software and etc. conference. So there are lots of great open source tools out there. Two that came to mind when I was putting these slides together are Apache Superset and NoCoDB, N-O-C-O-D-B. Those are pretty cool projects. Check them out. They do some of what I'm about to talk about. But this is certainly a strategy and how we can put all these things together sort of talk. So this is strategy, this is philosophy. We're not going to see code in the next 10 minutes, but we will talk about the actual strategy and the philosophy behind why I built my product the way I did, so that you can potentially replicate it. If you replicate it, go for it, right? Okay, so expected value over cost. This is basically, one of the things that I wanted to do was show that higher cost was lower, closer to zero, and lower cost was better, right? Because higher cost is not always better. So things like, can you find the record you're looking for? How do you know that you're getting to a record that you're specifically looking for? Are you sure it's the same record, right? If you search for everything having to do with printers, why printers is the example, I don't know. There's a printer over there. It spun up a minute ago. It's fresh on the mind. If you want to look for things that have to do with printers, how do you know that the records that you're pulling up from your archive are the same records that were going to get pulled up if you had done the search in the original system, right? That can be important for, especially the audit side of things, right? Does it have all the information you need? Most of these systems, it's not just as simple as a single database record. Even if you pull up a single record in the system, you're probably looking at 15 plus tables that are all being, SQL joined together, correlated together, lookup tables. Some of these systems can get really, really complicated, and 15 is like the low estimate. We're talking 40, 50 easily. And then things like attachments. This is always the thing that people forget about. Attachments everyone does attachments differently. Every system has a different way of storing attachments. Every system has a mind-boggling way of storing attachments. Some store it on disk, which, okay, it's a file. You're storing it on disk. It's still a file. That's great, I guess. But do you remember to get that file when you export the database? That's important. A lot of systems do store attachments in the database, but then there are lots of different ways of chunking up files and figuring out how to get them into binary blobs. And
I've personally seen problems with you had a crash, you restore the system, you've got the system, you've got the attachments are no longer connected to the records.
Yeah, so for those in the back and the recording, he mentioned that if a system crashes, you might be able to recover the files, you might be able to recover the database, but you might not be able to guarantee that the files in the database are still correlated to each other, which is absolutely the case. I've dealt with that, not in this lifetime, but previous companies I've dealt with things like that. That's absolutely the case. I have mixed feelings about storing files on disk versus in the database. I think right now I'm leaning toward you should store files in the database. Yes, there are downsides. There are performance implications of doing that, but at least you have a little bit more data integrity, consistency, confidence if you do it that way. So yeah, absolutely a concern, absolutely something that you should be top of mind when you're archiving any system. So what should you archive? So I mentioned regulatory aspects of data. So you should think about that. Related items, right? 15 plus different records being correlated. That's a ServiceNow specific thing. We can ignore that. Attachments, we just talked about that. And then metadata. Most of these systems, even if they start out simple, eventually they start getting into some level of customizability. And this is where you really start to split hairs. So in addition to the tables that store the actual data, you know, a change information or a project management ticket, right? What if you have custom fields in your Jira instance? Well, that's stored in a table somewhere, and that's what we mean by metadata. Okay, so that was everything about the expected value versus cost, and it actually started to get into fidelity, and something did pop up. Okay, so when we talk about fidelity, I like to think of it in kind of a layer cake sort of thing. At the very bottom, we have tables, right? And you can get this just by exporting a database dump. You have the tables, you have the records, they are all there. You can also do the same thing if you just export it to CSV, right? A flat version of the data. At the very least, you have the data. Okay, you check that first box. But can you do anything with it? It's still a little challenging. Well, it's a lot challenging. Relationships are kind of the next layer of the cake. Can you correlate record A or a record from table A to a record from table B, and ideally have the system kind of tell you how that's supposed to happen so that you don't have to document how these tables relate to each other, have tribal knowledge, and have to figure it all out again every time you need a record. That's not a fun place to be. Something that I'm going to call forms, which is basically the view of a single record and everything related to that record. So what we try to do is we try to make things look exactly like they looked in the previous system, because we're very ambitious about that. We don't want people to have to learn something new, and we definitely don't want to have to design a new interface. They're already familiar with one. Let's just try to replicate that. But one way or another, when you're building something for archiving data, you want to make sure that you can actually get to all the things that are related to kind of the base record that you're looking at. And then searching, right? Just being able to see things, great. But how do I get to this particular record? How do I get to this set of records? Potentially even getting into aggregating and reporting and that sort of thing, but though that's a little bit more advanced and not necessarily applicable to everybody. And then security. This is actually something that comes up a fair amount in our conversations, because kind of the base that you need, the base requirement is having all the data and being able to see it. But what if you want to expose or give access to this data to the original people who had access to the data? Most of the company probably didn't have access to every single record in the system. And the way that access control was governed was something in the original system. Do you want to rebuild that from the ground up? Do you want to try to leverage some sort of ACL that's already in the database? Something like that. So this is actually a big part of what our conversations center around. That's usually, we demo our application and then we get to the end of the call and someone says, okay, but what if people didn't have access to HR data? What can we do there? And we say, actually, we can solve that problem. And you can too, right? This is not, I'm not gatekeeping what we do. This is certainly something that, depending on the database that you're working from, there is probably something in there that says these people can see HR data, these people can't see HR data. But that's something that comes up very, very often. Oh yeah, and then attachments. I don't have attachments in any one of these layers specifically, because it could be in a different place depending on the system. It could be at the table level. It could be over here because they're actually files on disk. There could be weird relationships that correlate attachments with the individual records. It's the Wild West when it comes to attachments. So we go back to this graphic. So in summary, the fidelity and the expected value are definitely the kind of the key axes to look at. At a minimum, you have your database, and you can just go with that. That might be sufficient. But if you want something more from your archive, my recommendation is that you especially go along this fidelity axis and try to glean as much information from the raw data as you can. And maybe that layer cake that I showed on the last slide, it can be kind of a roadmap for, start at the base layer, make sure that you have the tables, and then start building up from there. Realistically, over the last 2.5 years, that layer cake, this is kind of the product roadmap that I followed. I started here and said, can I see the tables? Yes, I can see the tables. That was pretty easy. Can I see relationships between the tables? That was step 2, step 3, step 4, and then that was the hardest part. So definitely, that's my recommendation, is start simple and then gradually get more complicated. And don't take on any more work than you need to, but someone's probably going to ask for security, some level of security. Whether you build your own, because you only have maybe two groups who need access to this old data, so you can just build a simple security model on top of it, or you want to replicate the original security model. And sometimes that can be fun, sometimes that can be challenging, sometimes it can be both. All right. I think that's it. We covered everything. This is me. I'm Brian. You can contact me. This is my company. I realize that color probably doesn't show up very well on the projector. If you're going to be in Vegas in a couple weeks, we are going to be at Service and Support World. That's one of the big conferences in IT service management. And of course, Cute Puppy. And we're also over in the Expo Hall, again, across from the raffle area. So come see me, come talk about data migration and archiving and that sort of thing. And happy to answer any questions that you have. Yes?
So, what if you're going from just strictly a file system with permissions, folders, permissions, all of that kind of stuff, into something like SharePoint, where they don't use file permissions so much as labeling and categorizing, and it's like a paradigm shift, no databases at all, just files and massive amounts of them.
Yeah. So the question is, what if you're going from a file system or something like it? I'm going to kind of inject some commentary, and the key there is hierarchy plus ACLs, right? And going to something like SharePoint, where you don't have that hierarchy, you still have ACLs, and it has a different paradigm for organizing data, right? And I think that's really the key to focus in on, is what are the things that are the same between the two systems, and can you keep those consistent? Or what concepts map more or less one-to-one to each other? And then worry about the things that are different, right? Hierarchy versus tags and labels, and come up with the strategy for that sort of thing. I'm being kind of vague because your hierarchy could be, it's a hierarchy. It could be any number of things, right? You have to find something that works for your organization as far as what labels you choose to represent the things that you had in the hierarchy. It's been a while since I played with SharePoint, but I know there are games you can play to kind of simulate hierarchy in SharePoint. So that could be an option. Because everything in SharePoint is a list, right? But there's nothing stopping you from having a field on a list reference something that is a hierarchy, or have some sort of parent-child relationship between records. So you could make it work, and you could make it look almost one-to-one. But I think the key would be finding the line, finding the balance between the things that where the paradigms do match up, and keeping those as similar as possible, and then dealing with the things that are different independently as one-offs. And there might only, it's possible that you don't need to implement all of the hierarchy in SharePoint. You might be able to get away with just, we just need a status column, and that's sufficient. It depends on what you're using the archive for. But that would be my recommendation is don't bite off more than you can chew. Implement only what you need, and try to mirror paradigms as much as possible. Yeah. Question?
Why did you end up building something instead of using the open source options that you mentioned? Is it, you must have some critiques of those.
This was 2.5 years ago when I started doing this. Certainly at the time, and possibly even now, those platforms didn't implement some of the higher levels of the layer cake. So like security, and they might have had certain filters, but they didn't necessarily have forms. Certainly not built off of the metadata in the database. So that I would have had to build myself regardless. That I probably would have had to build myself regardless. Of course, I could always, just reinvent it or have that be more of a services thing than a product thing. The other thing is so as much as I love open source, and I really do love open source, there are nuances and complexities with having an open source product or using open source products. Lots of enterprises look at open source with a different lens than they look at proprietary software. It almost becomes so much easier to sell a company something that they don't have control over, which, just let that sink in. That is a crazy statement. But it is sometimes easier to sell something to a company that it's like a black box. But because they have someone to call when they need support for it, and there's a pathway for it, they have an established procurement process. Whereas open source is still kind of scary to a lot of companies. It feels like, okay, so this is just a bunch of random people who came together and built this thing. There's no support for it. It's community supported. If I'm going to pay for it, what am I paying for? Right? There's a lot of questions. And even from if we were to open source our product, which I'm not going to say it's totally off the table. I'm also not going to say that it's definitely going to happen. Open source is not as easy as just making the source available. Open source, in order to really get value from having something be open source, you have to build a community around it. There has to be a community that is willing to contribute to it. And it's a business decision, right? It ends up being easier for us to sell a proprietary product than to try to sell an open source product.
Makes sense?
My son and I were talking about this morning. He was saying this is why Chromebooks rule schools.
Mm-hmm.
Because they can just buy the box and support's built in and they're cheaper than the Apple that the rich schools can afford.
Absolutely, yeah. I don't know if the camera the camera definitely did pick that up. The microphone may have picked that up. Chromebooks rule the world because they're cheaper than Apple's, and there's someone to support them. Right? Cool. Other questions?
How did you come up with your logo?
I hired a designer. Sorry. How did I come up with my logo? I hired a designer.
Cool. Yeah.
Yep.
Well, I don't have a question, but I came to this talk not for any specifics that you do, because I'm not involved in that, but I do genealogy. I have archives, so I'm always listening. I'm not a very technical, I'm not a coder or that kind of stuff. I'm involved in the community. So I'm always listening for the principles, and all the principles are sort of what I already do, so I'm reassured about that.
Cool. Well, I thank you for coming to hear about the principles and the philosophy. I'm glad it worked out, having a more philosophically oriented talk than a technically oriented talk. Usually my talks are technically oriented. This is the first time I've done a talk at one of these that's a little more philosophically oriented.
Well, it's difficult for a person like me to find things to go to. So
I'm
the next
glad,
talk
I'm
going
glad
to
you
is at 2.
came to my
Yeah.
talk. All right. Well, if there are any other questions, I'll hang out for a little bit afterward. But yeah, hopefully I'll see you over in the expo hall later today.
Thank you so much, Brian.
Yeah.
Just reminded to stick around until the next guy comes in for the AV.
Okay.
Oh, the room happy after.
So I have to stick around?
Until the next person comes, yeah.
Okay.
Cool. I'm going to put this back in the baggie that I got it from in the box.
Okay.
because that is the instructions that Ricky and Leif gave.
Okay.
Thank you, staff people.
You're welcome.
Grab. Let's see.
I assume you're the next speaker?
Yes.
Nice.
And you wanted to use the dongle as well, right?
Yeah.
Okay, so I will take it out of the plastic bag. Alright,
There you go.
when you're done, you can just leave this on.
Yeah, I got my own. Should be okay. Let me try.
I will put it
Oh,
right here.
Okay.
That's the one.
Yeah.
Oh, then I use that one.
Okay.
Available should be.
Sure. We'll just go ahead.
I'll just get my stuff out of the way.
Okay, thank you.
And try not to kick anything over there.
And then go over here
Right.
and see if he's got any signal. All right. So he's
Good.
got signal.
Yeah, right.
Okay.
Okay, good, great. Yeah.
Okay. I'm gonna be in my next session now.
Oh, okay.
So you said you're over in the expo hall as well?
I'm sorry?
You're over in the expo hall as well?
Yeah,
You're here with a sponsor?
yeah.
Which sponsor?
From the communal project. So,
Oh, okay.
Yeah, the community sponsor.
Okay, cool.
Yeah.
Yeah, I didn't make it through the igloos area
All right.
yesterday because it was so packed with people I couldn't tell who was actually there. And,
All right,
Yeah.
okay.
So I'm hoping to wander through there this afternoon, so maybe I'll see you.
Okay, good, great, okay.
And then I'll catch your talk on the recording because I have to get back to my own booth.
Okay.
Oh, I should probably hang out until the next room captain shows up. Yeah, as you might, let me
X. Have you anyone here used Colonial before? Also, okay, at least 3. Okay. So yeah. So the reason why you want to use a rescue or backup tool is because you might have a crash problem, right? You are afraid of the crash problem. So yeah, maybe that's because of a hardware issue, or maybe because of a virus or something, a ransom software, something like that. So you want to make a backup for the whole system. Oh, that's one of the reasons. Another reason is you want to deploy the system, like here, the computer classroom. You are in charge of the computer classroom. You are in charge of the computer classroom, and you want to deploy the system. Otherwise, you need an efficient way to deploy the system. Okay, so that's what Colonial for. So you can have a temporary machine and do the massive deployment for the rest of the computers. So that's the reason why we have Colonial here. And that's the Colonial is we started this project actually around 20 years ago. Okay, that's been a long time. And actually, it's quite good, quite nice to be here. We have been participate to this conference from, I think it's 2015. Okay, so that would be great if we can continue. Okay, so yeah, this GPO system. The software we have support the GNU Linux, some of the file system here, and the major file system on Linux, and of course the Windows system, and the Mac, and yeah, we used to support the ESS4. The VMware, but that later because of some of the library issue, and so we can only support the older version of the VMFS. But still, it's support a lot. Here, and I think most of people they can do the system backup in different way. Like you can just copy the file. You can just async or something that's a copy way, like the Firebase, and then you can also use the DD command that's dump every sector, right? But sometimes you have maybe a 1 terabyte disk, and the used data only maybe just 100 gigabyte. You don't want to spend the time to dump everything, so you need a smart way to just dump the used data on the hard drive. So that's why we have Colonial with an efficient way. We have an engine called Pacron to use to detect the file system and just save or backup or restore the used block on the file system. So that's an efficient way. And we try another Unix way, like we use pipe to. It will be very easy for us to just get the data and pipe to maybe glibs or Pixie or SD and different compression program. Then you can just set the image. So that's the Unix way, and with the pipe way, and that's easier for us to develop the system. So that's the way we have. Okay, so to deploy, as we mentioned, we have a different way for Colonial, like just one system backup and restore. You can use Colonial Live. And you want to do a massive deployment, you can use a live server, Colonial Live server, or the server edition. Okay, there are different scenarios for you to use. For live system, just one machine that will be easy for you to use, and you can just use the USB flash drive or CD. Okay, nowadays not too many people use the CD, but still a way. Okay, you can do that, especially in a virtual machine or some of the you want to deploy backup the system. That's another way you can try. Okay, so that's a live system, and then you can save the image to the network file system or just local file system, like local device, local media. And for the live server, you can use a single USB flash drive and put the temporary machine as the server, and just deploy the system to the rest of the computer. And we also have a special BitTorrent protocol. It's also another project, EasyIO, from a developer in Taiwan, and we use that one and to do this kind of massive deployment. Okay, And of course, the live server is also support the multi-case or broadcast. I didn't put it here, but it also support live. Okay, and for the live server edition, you sometimes like in the computer classroom or in a machine room, you want to have a fixed machine and to keep the system consistent, and you don't want to change everything. So now you can have a server edition and install everything, and that's fixed. Not like the live server, you put machine every time. Also, not a different scenario for you to use. Okay, so like as I mentioned, for the multicast, it's one of the network protocol, and you can just use UDP. That's also another program. Okay, and to do the multicast or broadcast for the package, and you deploy to the client. Okay, and yeah, that's been a long time. Multicast around 20 years ago, we have this mechanism in the Colonial Live, in a Colonial system. And later, about 10 years ago, we had a BitTorrent provision way to do that. As you know, that the BitTorrent, the BT way is every client can be the server. Okay, it's a seeder or leacher. Okay, so that way it make the deployment more efficient, but it still have some of the a nice way to deploy this system with a BitTorrent, but it's not. You in Colonial Live, you have to prepare the system, and you have to pass the file system first. So in the beginning, it would you need spend some time to make seeding the server or some. But for multicase, it will be easy. You just directly read the file system and do the multicase. So there are two ways you can use for the basic deployment. Okay, so as we mentioned that you can use Colonial on x86 machine, you can use on ARM, and you on RISC-V. And here we have a RISC-V laptop here, and later we will do a demonstration. But because the demonstration the machine we have in Taiwan, in the laboratory here, there. So I will use a SS command to connect to that machine. And this one is only for the demo in the booth. So later, if you are interested, you can come to go to the booth, and we can do the demonstration. Okay. So as you might know, last year we gave a talk about the RISC-V, and let's talk about 11, and we have another topic for the RISC-V, the massive deployment for the RISC-V. So later we will have more details. Okay, but this popular system, actually x86 is definitely the most popular, and ARM system getting popular. But as you know, ARM system is very diverse. Okay, different ARM have different maybe the firmware issue or something. So we have a Colonial Live for the ARM edition, but it's not so mature as x86. And we have another RISC-V Colonial Live version, but as you know that it's very difficult to find a RISC-V machine. So yeah, so that's we actually do not have too many chances to test on different kind of the RISC-V machine. Okay, so we all put a Colonial Live on our website, and you can download that. Okay, so just give it a try if you have this kind of machine. Okay, so that's the ecosystem we have. So the base system is we use the Debian or Ubuntu as the live environment. Okay, and the engine we just mentioned is Parkeron, and Parkeron for a file system engine, and we use the many utility, many program from the Unix system, or like SG disk or something like that. Okay. And we also have, as I mentioned, we have a BitTorrent program, EZIO, and multi-case UDP case. That's all another from another project. Okay, so that's the total system we have. You can see that's a Unix way. We combine many things together and make it easy for us to maintain. All right. So as I mentioned, we have a booth there. So in the afternoon, if you have a chance, visit our booth, and we can do some of the demonstration for you. And right now, I would like to do some of the demonstration. Okay, the first one is we can do to put Colonia on the S86, and I will use virtual bus. Okay, here in my machine, the machine I have here, and I will try the ARM S86 that we put on the machine in Taiwan, and we will. It's a ASUS GS10. It's the NVIDIA the GB10 small box. Okay, that's from it's a great. It's an ARM64 CPU, and we run with QEMU. With another machine with the QEMU that will be faster than run QEMU on the S86. Okay, and we also try to put a Colonia on a RISC-V machine, or that will be a QEMU on S86. So we'll try these 3 different ways. Okay, that's the first one we have. I mentioned the first one is the virtual bus one. Okay, and here we already have a running system. That's I'm sorry, it's a little bit smaller for you to watch, but to read. But it's a bookworm Debian system here, and I want to switch to another operating system because I already have saved another image. Okay, so here this one, if you want to back up, it's quite similar way, and we have a step-by-step on the website here. I'll show you. So because of the time, I will do some demonstration quickly, and I won't follow every step. Okay. As I mentioned, the step-by-step, you just go to the colonia.org and you can check this step-by-step document. And here you can have some of the screenshot for the step-by-step to save the image or to restore the image here. Okay, and now I want to do on this machine is I will save the image and switch to another. Before I switch to another system, Debian system, I save the image. So to do that, you first have to download the Colonia Live from the website. Okay, and here on the website we only have 86 on the official website, and you can download either one. And I have downloaded one to save time for the demonstration. I have downloaded the first one, this one. Okay, so okay. As I mentioned, I want to replace this system with another one, but before that, I back up this system. So I have to shut down this machine. And the virtual bus here, we have used a Colonia Live ISO file. Okay, here, this one. Okay, and I put on this virtual machine, and we put Colonia Live with. Oh, sorry, I have to switch to boot from the CD. Okay, from CD. Okay, and okay, now you can see. Oh, all right. Okay. Anyway, that's a boot menu for Colonia Live, and that's the first. Normally, you just try the first one. There are many different choice for you, and you can check the step by step. There are some details. Okay, so here, as I mentioned, we want to save the image. Okay, the time should be enough for me to save an image and restore another one. Okay. Okay, that's the booting process. You can see. Okay, that's for the first one. You choose the language. I will choose the English, and choose the keyboard layout. I'll just keep the US keyboard layout here, and I choose to start Colonia Live. Or you can enter the shell to do some of the the maintenance or something you want to do. Okay, and I want to do the device image process. And I want to save it on the image repository. I choose the NFS server. The NFS server is actually on this machine. Okay, this my laptop. Oh. Or you get an IP address and from DHCP server, and here we can sync the time, but I want to save the time. I don't want to sync the time from the NTP server. So I mount the NFS server and I save the image on the NFS server, the repository, the path for the repository. So the image repository is ready now, and I want to save it. So I choose the save disk, the whole disk. And the image name, you just give it an image name. And I will just keep the default name. And then choose the disk. And choose the compression level. And choose the to do if I want to do the file system check for the source partition. And this one, do you want to check the saved image? I will skip this one to save time. Okay, and this one is for you to encrypt the image. You have the choice, you can encrypt the image, but I will skip this one. Okay, and this one for you to copy the data to the process, the log file to the USB flash drive. I will skip this one. And this one for you to reboot the system or to shut down the system after the image is saved. So I will just choose, later I will choose now. So you have the command, green command is for you to do just one command to do that. Okay, so now you will start save the image. I say yes, okay, it will save the image to the server, okay. So if you have done this many times, it's quite straightforward. But for the first time, maybe you will feel it's very primitive, the interface. But that's the way we think, and the efficient way, the command line, uncurses, that's new curses, uncurses, that will be easier to do that. Okay, so, and we have very limited manpower in this project, so we just get a thing done now. Yeah, I know. We know that the interface is old fashion, old style, but it get the work done. Get the job done is the most important thing for us. Okay, so it's done so quickly. Come on. All right. So I have a separate image, and right now I want to restore image. Before I have saved the image on this system. Let me. Okay, hold on. The machine I have, we have some of the image like this is the one I just saved, okay, and we have the bookworm, Buster, Tracy. Okay, so I want to switch to this system, the image I have. So right now I want to. I'll do it again, and keep a repository here. So we back to a Korean menu, and we do it again, and this time the repository is still the same one, and want to do the restoration, restore the whole disk. And this time I choose Tracy, okay, and restore to the SDA disk. Okay, I'll keep the partition size. I don't want to check the image size because in the previous I have done that previously. Okay. All right. So we just quite similar. You have a green command. Next time you can just use that command, and it asks you to make sure if you want to try, want to restore the image. Okay, I double check and I say yes to this, and it will just do the restoration. Okay. And that's the first partition. Oh.
We got a question here.
Oh, okay, sure.
Do you have tools to change, like the host name? If I'm pulling a whole bunch of computers, last time I tried to do it, all the computers came up with like the same host name.
Oh yeah, definitely. That's what Chrome for. Yeah, and your system is a Windows or Linux system or?
It it was an Ubuntu system.
Ubuntu, for Ubuntu, and you want to change the host name or
Yeah, host name
Okay.
and a couple of usernames and stuff like that.
username? Okay, for the host name, actually, you can assign that if you use a DHCP server. It's possible you can assign
Okay.
that on the DHCP server. Okay.
Okay.
But if you want to change without the DH server, if you want to do that, maybe you can use the Ansible way. Or that's maybe that's overkill.
So-
Maybe that's overkill. But not, you have some of the tool you can just check and there's some way to do that. As for the username, it will better to use. I mean, like another server or something. You have a centralized accounting system. That will be easier.
Okay.
But for single machine, you can like as I mentioned, like Ansible or something, you can post a process to do that. But for Chromia itself, it doesn't provide that tool. But you can have some script or something to do that definitely. Yeah.
Okay.
All right. Okay, so it's done. So the restoration is done. So we can just reboot the system with the one we have. Then they will check this one if it works well or not. Okay. So that's okay. You can see that's a Debian system. Okay, so you Debian 13. Okay, that's the one. And I will just shut it down. Then we will do another demonstration. As I mentioned, we want to do the demonstration for the ARM architecture. So I mentioned that the machine is in Taiwan. Okay, so that's the machine we have with the GS10. Or I mentioned that. So. I'll show you that's the ASUS GS10, okay? That's the ARM architecture, and we put that machine with this operating system Ubuntu. Okay, so right now I want to use the QEMU, and we have a script to do that. That will be easier. So. That's the script I have write, but actually it's just a QEMU command, something. So I will just run it, and you can see. Oh, yeah, that's actually because the boot menu is a little bit. I use SSH to log in that machine, and the layout, the skin for the color is it's ugly, but you still can tell. Okay, that's the boot menu. It's not a graphical one. It's just a text mode. Okay, that's the one normal boot menu like this. Okay, only alive. Okay, so I'll choose the first one. Yeah. Okay, and the menu didn't come up, but we still can run it with Chromia command, and you will have a menu. Before I start the command, we make sure it architecture is, as you can see, that's the ARM architecture name. Okay, so I won't do too much restoration again, and it's quite similar. So I will just show you this Chromia I can put on this machine, and with the same menu. It's no matter it's x86, it's ARM, or later you can see it's RISC-V, is all the same. You can do that. Oh, okay, I will just stop here for the ARM architecture. And I want to mention that, and another one is with the multicast. Okay, and right now I want to do the live demonstration here, and we use the server side. We use the Sci-Fi machine and the image layer. Okay, and I will start Chronia and set this live server and choose BT from the image. That's the server. Client side we have a DC Roma. Also, the machine is in Taiwan, and as I mentioned, there's no PSC, so we have to put that machine to Chronia Live, and then we run the command. Okay, that's the scenario we want to show. Okay, so let me. Okay. That's a sci-fi machine. I can show you that we already put that machine, and that's a RISC-V machine, and we already put that into the Chronia Live. I'll show you the live version. Okay, there's no. It's customized. Yeah, that was different version, but we patched something. Anyway, we put that one. Okay, so this one is so let me clean it. Here we have the image here. We put the image DC Roma. We set it previously back into January. Okay, then later we'll do the deployment from this image to the DC Roma machine. So right now, as I mentioned, we start Chronia server, live server here. Okay, and we want to start the live server, and the client will boot from the local media. There's no PXE booting, so we don't choose the first one. Okay, we choose the local booting only, and the server side, we just enter the beginner mode, and we want to do the messy deployment, and we can do from the image or from the device. Or because, as I mentioned, we have different type of machine. One is a sci-fi, another one is a DC Roma. So we can use this one because they are different type of machine. So we just use the images that saved on the sci-fi. Okay, we choose from the image. And we choose to restore the full disk. And that's the image I just mentioned we saved in January. Okay. And we want restore to the NVMe disk. And we use the key partition table from the image. And we don't want to check the image here because I will want to save some time, and I have checked that image previously. Okay, and after the machine is done, I will just choose to stay in the command. I don't want to reboot the machine to show you the steps there. Okay, and we can do the multicast, the broadcast, or BitTorrent. Okay, here I'll choose the BitTorrent way. Okay, so you will start the seeding process. Okay, you can tell there are many partitions. The image is saved by the partition, and there are many of the torrents information. Okay, so now you add all the partition to the seeder. Okay, now the server is ready. So I will switch to the client Leisure. Okay, this is a DC Roma machine. I will show you the architecture is the RISC-V. Oh, maybe it's too. Let me. Okay, that's the RISC-V. Oh, wait. Hold on. Oh, yeah. It's all dark, so background, so I was confused. All right, so that's a RISC-V, and as I mentioned, actually in the server side, it will tell you that you have to run the command like this one. Okay, the IP address actually the server side IP address, so it's different. Okay, so and I will just paste. Okay, so you get information from the server side, and the configuration file is already inside that machine, and you will get follow the confirmation file, and we'll just do the deployment. Okay, that's for one of the client, and if you have another client, you can run the same command Of course, you have many of clients, you won't do like this way. For SATC, like in computer classroom, we actually just the PhD booting and all the steps is unattended, just go straight forward. But because, as I mentioned, this one is still in the early stage, there's no PC booting in this machine, so we have to emulate the way. But it's the idea, same idea. And that's the client teacher, they want to add to the torrent right now, and add one by one. Okay, then you can tell that some of the partition is very small, so it's just get just a few bytes only. And this one is for the total. Actually, there are too many partitions, so I will scroll down. That's the one. This one, okay. This one is for the root file system.
Yes.
Okay. Yeah, so you can tell it's going, like this way.
Is the Pixie boot limitation of the RISC-V architecture, or just bootloader?
But I'm not really sure. Do you know that?
Maybe in a different. Yeah.
64 is like the bit size of the architecture, like RISC-V and x86, like they usually have like 64. There are like some examples of 128-bit architectures, but mostly
I mean the
64.
RISC-V.
It's register size of the registers, and
Yeah, this gentleman is from Ventana, so he's familiar with RISC-V. Yeah.
sorry.
For PXE network
The
booting.
64-bit is actually the size of the register.
I'm not talking about 64-bit. I'm not talking
Okay.
about the bit architecture.
I see.
My question is the net booting limitation of not being able to Pixie boot, is that a limitation of the bootloader or the?
That, I don't know that. That's
Okay.
maybe specifically.
Okay.
Yeah, maybe we'll have to dig more. We'll try to
Okay.
find a reason why.
Okay.
But it's just not available on this machine.
Yes.
So that's the reason why we have to use another way to emulate the process. Okay, and for the BitTorrent, even everything is done, we have to still wait for a little bit for other leader to connect to this machine. Otherwise, the server, the seeder will be the bottleneck. Okay, so if you are familiar with the BitTorrent mechanism, that's the way. Yeah. Okay, so we have to wait a little bit, and I think we said it's 2 minutes or 3 minutes. Okay. Yeah, during while we are waiting, maybe you have some questions, please. If you have, please ask.
I hate asking because I came in late.
Yeah, you can
messed up
still.
my schedule. But
yeah.
which actual hardware are you using for this?
For this build, that's a DC Roma, that's a RISC-V data.
Okay.
Okay, but actually we have another one in Taiwan. So right now we connect SH login to that machine and do the the restoration. And here this one is for demo purpose, and we can show you in our booth later. Okay.
Oh, okay, guys have your booth? Okay.
We will have a booth there. Yeah. In the afternoon before 3:30 we can come to our booth and
I
show.
did see, I didn't realize it was a risk fee.
Oh, yeah. But it looks like just a normal data.
Yep.
Yeah.
So this is a sci-fi processor that you're using? Sci-fi processor that you're using for
Inside? No, I don't think it's sci-fi. Sci-fi, we have another board in Taiwan. Yeah.
Okay.
I will have to check the spec for. Yeah.
It's a SoC is a K1. CPU.
K1.
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 Mm-hmm. Come on. We get so long. Oh, okay. Finally. So for the client, the leader is finished the job, and you will do some of the post process. So every partition is deployed, and you can see the file system checking something like that. Okay, so yeah, basically that's the idea. Okay, and here we don't reboot that machine because once it's rebooted, we still cannot check. So I'll just, because it's remote. Okay, so there's no camera watching, so I cannot show you it's really boot well or not.
I believe you.
Yeah, but that's the idea. That's the idea we have. Yeah. So, yeah. We still have about 10 minutes. Then maybe you have some other questions, or we can discuss more, or in the booth later. Yeah.
Yeah, I'll probably swing by the booth.
Okay. Yeah, please. Yeah.
I feel bad about missing that. So.
Yeah. No problem. And we will put the slides on the website, and you can check later. Yeah. But for the risk fight, it's quite interesting for us. Just there's not too many machines we can acquire. So if you know, then let us know. Okay, especially the laptop will be the perfect one. Yeah, it easy for us to bring to show to demonstrate. Okay, for the P550 the board sci-fi. Oh come on, the board is so small. And then they gave the power even larger than the board. That's ridiculous. And because one board, I think it costs $500 US. And also the power we would like to change to like the laptop use the small one, but we are afraid maybe it will damage the board. So we keep that one in our laboratory. So so laptop will be perfect. Yeah, for this kind of purpose. Yeah. So if you do know that, please let us know. Yeah, and we'll try to buy one.
Well, the Frameworks has one.
Yeah.
You go through. Oh, you already talked about that. So that's why I say I feel bad about coming in. Okay, they don't sell it, but Deep Computing sells one that will go into the Frameworks thing.
The Deep Computing has apparently a motherboard with this pipe, but I don't know which, probably sci-fi as well. But
yeah.
You mean deep computing?
Deep Computing.
Yes.
That's a Digiroma is from
Digiroma
is from the Deep Computing.
Yes.
Yeah.
Okay, so that's their non. Yeah, because they have their own laptop and then they have the other one. Okay.
Yeah, from Deep Computing. Yeah. But it will be even nicer to have the one not from China. I mean, because we are a national lab in Taiwan, so sometimes we are, for the laptop it's okay. Yeah, it's just buy and that's fine. But for the machine, we want to put in the machine room. Oh, yeah. So, but we'll try. No problem. We still can try. Yeah.
What Linux distribution are you running?
This one?
Yeah.
Debian or Ubuntu will be
yes.
fine. Yeah, they came with Debian or Ubuntu. Two choice we can try. But for the Colonial Live, we use Ubuntu for Debian at the moment. Yeah.
Well, hopefully soon you'll have the choice of Fedora, CentOS Stream, and
okay.
has one, but
I believe, yeah. But for Colonial, we because it's just one-time purpose. You just use to deploy the system, and so we didn't spend too much time on different distribution. Yeah. But if you want to run, of course, I believe some people they are familiar with the Fedora series. Then that would be easier. Yeah.
There is this, I think there is this organization that works with the RISC-V called RISE, R-I-S-E. So they RISE.
I know. I know that one. Yeah.
And RISE is, trying to develop this software ecosystem for RISC-V. So I don't know what they have like distribution-wise, but if you want to explore that one place to check.
Okay.
I know a lot of people are involved in the RISE.
So, in this,
yes, please.
again, you might have said this earlier in talk. For your software, what was the hardest thing in porting it to RISC-V?
For the package itself, I think it's not a problem. But for the firmware driver and the tree, you can explain.
We have, for each machine, we have to identify which package, which kernel, which firmware package is used. So we have to do a kernel swap command to change the kernel firmware device tree file into for the specific hardware. I think that's a diverse,
Very diverse.
very diverse and for different hardware. That's the most important. But most hard part for different hardware, but not difficult. Just diverse. Yeah.
Yeah, just one by one check and yeah.
That's because they didn't upstream the.
Not one of the reason. Yeah, not one of the reason because still maybe the upstream they don't accept this kind of driver or something. Maybe it's because they didn't submit. Yeah, I'm not really sure, but that's the pain. That's the pain because of the kernel, the upstream kernel. I mean, we use it from Debian or Ubuntu. They don't cover every hardware for the RISC-V. So that's Caesar just mentioned. We have to check one by one. So that's the reason why in the beginning we mentioned that for the. Hold on.
Oh, okay, yeah, you said it at the beginning, I'm sorry.
Yeah, in the beginning here we have to do a customized image, especially for DC Roma, and we have to use this one and DD to the SD card. We cannot just do the normal SATC Coronia way, like just download the Coronia lib file and unzip to the USB drive. That's straightforward and easy because it's quite universal. And this one, no. I think that's the most deep card we just mentioned. Yeah. Okay. So, any more questions? Yeah. Yeah. So if there is no more questions, then okay, that's the end of our talk. Thank you very much. Thank you. And please come to our booth if you have more questions.
Yes.
Okay. Our discussion we can try. Go ahead.
Thank you.
Okay. Thank you. So I just unplug. Okay.
Yeah.
Okay.
Yeah, that's fine.
Okay.
I'm barely allowed to touch this stuff anyways. There's a guy in the back that has
All right,
remote
all right.
access to everything.
Okay. Great. Okay.
So how long have you been working on this file?
About 1.5 years. This topic is about years ago. So this year we also have
I hear that. Yeah. So like in Taiwan, like Taiwan is this file, like people want to know this file.
Actually, in Taiwan, a lot of companies, especially for chip designs,
Yeah.
for example, Andes is a Taiwan company.
Yeah, I saw this. Condor, like my friends work in do you know Condor Computing?
Condor Computing.
Condor Computing.
Condo. I know the condo for HPC, but
Yeah.
is it the same one? Condo computer.
Condor Computing is basically a company in Austin, but they are like a subsidiary of Andes. So they have been doing RISC-V processor development. I have number of friends working there.
Oh.
Yeah. Okay. Yeah. So Andes is
Thank you.
Thank you.
Yeah, they have chips, but there is no, they just, I think they still.
Yep, okay, if everybody's out, we're having lunch, so.
Okay. I didn't know if I had to.
Nope, I'll do it and I'll lock up. Yeah, you just wait for one of us to come and then we lock the room up.
Oh, okay. Thank you.
Yeah.
I just want to mirror it. That's the thing.
Yeah, so this will be the setup. And we've just got HDMI, I think.
Yeah, HDMI should work.
Yeah.
But there's like, I have to, say the ancient.
Yeah.
So.
Good to do a little prep.
Yeah, well, I already established that it didn't work, so. Should I just turn on this guy?
Oh, it should automatically turn on.
It's not. Oops. I'll try plugging it in again. Oh, that's a different, this is not plugged in. This doesn't go any, oh, this goes to this guy? There's a dongle.
Short HDMI to HDMI.
That's
Maybe let's try the room next door.
Okay.
I don't know if this one's been disconnected for lunch already.
on and leave the ones with the projector off.
Okay.
But you can kind of do whatever the speaker prefers if they have a preference.
And then what's the login? I forget.
For excellence. So, for capital E, XCELANCS, and then an exclamation.
Okay. Looks like it's working now. Sweet. To eat. Okay, sure.
Hello.
Hi.
Yes, I'm going a little bit. You want to be here?
You sit in front.
No, no, I'm not going to the, you sit front. You have a short coat with Karen. She's okay?
Yeah.
You know about her?
I asked her, I already did. I asked her what my great-grandmother's maiden name. She looks like she knows. It's Weeks. Weeks.
She's okay, right?
Yeah. So I found out something else. Put it in my file.
Yeah. She's busy for quite a long time.
Not really, but I asked her if she'd done it. She hadn't, so she said she's going to do it, so maybe she will do it. Who knows?
We asked the bank and all this stuff.
She said it looks like she's going to do that first.
Yeah.
Let me just do this. Wood. Yeah. Yeah, 45. Okay. Okay. Mm-hmm. Okay, so originally, the father's name was Week, but the lady in the house, who was the gardener, didn't like the name Week.
That would be me.
E-E-K.
Yeah.
So she, in those days, she had a lot of power.
Mm.
She changed his name to Weeks. She couldn't shout Week, didn't
Yeah.
sound right, so she changed it to Weeks.
That would be the way the last one. That would be,
It was Week.
yeah.
She changed it to Weeks.
Who is the week? How do you know weeks?
Karen had told me.
Yeah.
Why?
So we changed it. Now I put it down.
Yeah, yeah.
Oh, a lot of power, huh? Mm-hmm. Yeah. How about the week? Sounds like your week. Weeks. Right?
Yeah. Look at that, amazing. There's another one in Market Drayton. Shropshire Stone, Margaret.
The one? Which one?
That's, sometimes you get family members like that.
You got it?
No, it's not the same one.
Hi there. The speaker. Do you have an HDMI port?
No, but I have an HDMI to USB-C.
Okay, so we actually have a USB-C too, so we can try this one. If there's any issue with it, we can always use yours too.
Sure thing. Let's see, same internet?
should be Linux best.
Okay. Sign out. There we go.
Yeah.
Ooh, that's a bit of laggity lag. Okay, come on. Ah. Okie doke. That works. Double checking my slides.
Okay.
That is not settling in right. So see, we got a lot of people who are really interested in security here. This is going to be a lot more fun than the talk about FIPS. I'm sure everyone's really disappointed that we're not getting into FIPS 140-3. Happy to diverge into post-quantum cryptography if anybody is particularly interested in the trials and tribulations of getting that shipped.
I am.
I will happily talk about it. Right now, you've got some significant new requirements like CMMC, particularly for CUI. Universities everywhere are freaking out because they've got all these new requirements. There's all these requirements saying you have got to move to post-quantum cryptography by 2030, 2035. Things are getting phased out. You're like, all right, got it. I'm ready to move. Turns out there's not really any PQC you can implement. OpenSSL's it. OpenSSL and NSS, for at least at the enterprise Linux level. libgcrypt, still in development. GNU-TLS, still in development. The kernel, just barely starting to get tip of tree. So you're like, oh great, I'm an enterprise. I'm ready to go deploy PQC and follow, be compliant. Where is it? You don't really have much you can actually deploy right now. Yeah. So what do? Well, if you don't have C-bombs, now's the time to get some C-bombs. Cryptographic bill of materials. If you haven't heard of them, I highly recommend. Companies like Binarly make it way easier to figure it out. Very interesting thing we saw with the transition from FIPS 140-2 to FIPS 140-3 is a lot of our customers, when they were rolling out the new FIPS 140-3, I'm like, hey, here are some algorithms that are no longer allowed in FIPS 140-3. Like, oh, we don't use those. And then they grabbed we're like, you should just test our versions while they're still going through lab validation, just in case. Turns out there was some dependency using those algorithms and took them months to back their way out of it so that they actually could be compliant and run with FIPS 140-3 modules. So a cryptographic bill of materials, especially as PQC is coming out and like SHA-1 deprecating in I think 2030, now is definitely the time to start taking inventory of what algorithms are out there in the wild. And if you start tracking it now, then anytime somebody decides to shove some random thing and deploy new software, now you've got a way to track it and know, hey, you can't add that because that's going to be moot in a year or two.
Yeah, I'm just sort of wondering what Git's going to do because they're using SHA-1 more as a hash and not a security hash.
What we definitely have heard a lot of people talking about, like a lot of build tools are still using like insufficiently strong encryption. If you're trying to sell quantum computers, you're gonna be like, it's here tomorrow, it's coming, you gotta get going. But a lot of the conversation has been, it's not ready. Even 2035 is very ambitious for it to be actually deployable in production. And then the next week, Google drops a blog and they're like, oh yeah, no, it's here, we did it, and suddenly every fintech company in the world is freaking out. We don't even need to worry about AI at this point. This is quantum computers cracking cryptography is way scarier than AI. Let's see.
Half of the Bitcoin ledger is...
Oh yeah. Oh, that's, yeah.
Is there a hardware component to that? Like I know that most modern platforms have hardware accelerated cryptography.
The hardware, yeah.
Do those same chips still accelerate the post-quantum?
We have seen increasingly that as the jitter requirements go up and the entropy requirements go up, we've started to find edge cases that nobody really expected where there's struggles. And I don't have all the details. I work with people way smarter than me who understand how it actually works and the implications, and I just kind of absorb things through osmosis. But definitely with the hardware vendors, they're out sprinting ahead of this as much as they can. If you go to the NIST website and see which, who's actually pursuing algorithm certification right now and trying to get their PQC in now, a lot of it's hardware. All right, looks like we're about ready to get started. Make sure my tests are ready to go. Okay, are we good?
Yeah, you're all good.
Fantastic. So layered security hardening in Rocky Linux. So Hi everybody, my name is Brady Dibble. I am a Director of Product and Technical Program Management at a company called CIQ. We are the founding support and sponsor of Rocky Linux. You may have heard of it. It's a successor to CentOS and one of the most popular enterprise Linux platforms in the world. At home, I've got a little desk Pi on my desk that I'm trying to suck up all the power and increase my power bill, but I have a lot of fun toying with enterprise-grade software on it that is way overkill for what I'm actually doing with it. And then, I've always loved the plumbing, the underlying plumbing of how things go. I started in the kind of e-commerce and food delivery space where we had a very complex marketplace and all these apps shipping to customers, but every time there was a problem, you got to go one layer down. Okay, what the heck is a lamp stack? All right, and you start going down every acronym. Why is our PHP multiple years out of date? Why is that a problem? What is this magical black box that makes all of these things happen across millions and millions of orders? And so over time, I worked my way down to the Linux stack, and I'm having an absolute blast getting deeper and deeper into the nuances of running enterprise Linux at scale. One of the things we've run into frequently is, even as people talk about AI, and CIQ, we do a lot in the HPC and AI space, compliance and security are always close. Even while you're trying to, a lot of companies are sprinting ahead of trying to get prepared for AI and be able to run AI at scale. And for a little while, they were willing to kind of sacrifice things like stability and maybe even security in order to make sure their brand new NVIDIA stacks ran. But they're very quickly realizing that, all right, now we got to catch up on the security and compliance space. We can't run ahead of it forever. So if you're a sysadmin and you are running, like, taking a generic distro and then hardening it yourself, trying to keep your stuff secure, this talk is for you. If you have your own home lab and you're like, hey, I've got stuff exposed to the internet, and now every Tom, Dick, and Harry can grab a local model and start banging on my front door, this is for you. If you're an offensive or defensive security, that's definitely for you. You probably know some of the people I'm going to talk about. And if you're just, if you're running Ubuntu or Fedora and you don't really have a lot of, touch the enterprise implications or the experience of enterprise with Linux on a day-to-day basis, this talk is also for you. So one of the beauties of Linux is that it's flexible. When you go to a distribution like Rocky Linux and download a QCOW or an ISO and go install it, it's intended to be flexible because they don't know what you're going to do with it. Got a bunch of packages, your generic server groups, or desktop workstation groups. But by default, if you look at Linux as a house, it has a door and it has windows, but the door is unlocked and the windows might be open because it's got to be flexible. With enterprise, they take that house and now they got to go around. You got to lock the doors, you got to close the windows, you got to put on bars on the windows, you've got to overall harden the house. But most of these at this point is configuration level changes. You may have heard of CIS or STIG, even PCI DSS and HIPAA. They all have their own set of requirements. And what you do is you go and you modify all these configurations to harden the operating system, and then you run scans using tools like OSCAP to be like, yep, I'm compliant, I've turned off all of these settings, I've locked the doors, I've locked the windows, I'm secure now. Unfortunately, that isn't really enough. Because if your door is still made out of balsa wood, it doesn't matter if it's locked, someone's still going to be able to get in if they try hard enough. So when we look at hardening from a CIQ perspective, we look at not just the reactive, which is, okay, I've got a CVE, someone's identified a CVE, now I've got to patch that CVE. We look at how do we start preventing hardening, preventing exploits from the beginning, and then how do we ensure that there's no such thing as a secure system. The most secure system is a server that isn't connected to the internet, that you put into a concrete box and you dump it in the middle of the ocean. But unfortunately, it is not very functional at that point. So there's some middle ground between completely inaccessible and unusable and completely open and free. And so that's where we know that we can make something more secure. But you can never completely prevent someone from getting in. So when you cannot completely prevent, you detect. And that's basically the next best thing. Especially with AI, I think everyone's heard about how many CVEs are just propagating. With AI in particular, though, more people can find exploits, and then when exploits come out, especially when they're published as a CVE, you can turn those into an exploit very quickly and start spamming it everywhere. And you don't even have to be very good at programming. Enterprises can take quarters to patch. And the kernel in particular, ever since the kernel became its own CNA and published its own CVEs, they're publishing thousands and thousands of CVEs. Most of them probably don't matter. Most of them are like really obscure CVEs for obscure drivers. I think maybe people have heard about certain old mice are no longer supported, old devices are no longer supported. AI was finding all sorts of CVEs in these arbitrary drivers or arbitrary features that no one actually uses anymore. But when those CVEs are found and those known exploits are discovered, enterprises can sit there and be vulnerable for days, weeks, or months. And that is a long time to sit there and just hope that nobody happens to catch you at the wrong time with the right exploit.
Pour one out for ISDN.
So hardening is what you need to do in the meantime, because you can't outright prevent it. And if you're waiting for the patch, as an enterprise, even if you get the patch, even if the distribution says, here's the patch, go patch it, well, you might not be on the latest version. You might be locked in or pinned to a minor version because you're not ready to move to the newest kernel. So you might be on an LTS version for a while. Or you might be, certain institutions cannot risk. The risk of instability is a cost of millions and millions of dollars if server goes down. So they have to go through very exacting process to review every upgrade before they push out every single patch. And so they will wait weeks or months before they actually patch their systems. Not to mention, taking systems down yourself, particularly to patch the kernel, is also costing you money. So you're shooting yourself in the foot. So it's a constant game between, do I lose a ton of money with my very expensive NVIDIA NV72s going down for a couple of hours? Or do I just take a risk and hope I don't get, slapped? That's where hardening comes in. Now, as we talked about, most of the hardening you hear about, the term hardening is guides. Like you'll run an Ansible playbook against a server, and it'll apply all these configurations, and then you run OSCAP, and it says, look, you're a good boy. You've got 97, 98% compliance with this guide. You go, great. I'm secure. I'm hardened. Excellent. That's just the start. You got to get down to the code level and start changing things there. That's where we talked about the balsa wood door versus getting to like at least a decently wood door, or if you're lucky, a metal door. So that's three components. There's hardening packages themselves. By hardening individual packages, you can mitigate entire CWEs, common weakness enumerations. That's like a definition of here's a type of exploit that an attacker can go against. You put it in a box and saying, hey, these are a particular attack surface area or attack vector. Let's see what we can do to mitigate that whole scope. And then runtime detection. We're going to talk about Linux kernel runtime guard, which is a tool that is open source and you can run it right now. And it sits in basically next to your kernel and it detects if anybody is messing with it in a way that is unusual. And then at that point, if it detects that, it can shut down your whole system, save you from an attacker actually getting control or being able to do something malicious. That's when there's a container escape and someone gets into your kernel. You can't patch it, it's too late. You couldn't prevent it, but you can detect it and take action at that point. And then once you make all these modifications, one of the biggest challenges is keeping them every time you reboot. That's where control comes into play. So, couple of these, I think I lost my... Yeah, there we go. So there's 6 packages what we're talking about. In Rocky Linux, in the Security Special Interest Group, there's 6 packages that you can go grab right now that will replace some of your existing packages. For example, it replaces the glibc with a hardened build of glibc. It's hardened malloc, which is an extra package which hardens the surface attack area around memory allocation. It swaps out the default password manager for Enterprise Linux with Password QC and YesCrypt, which I believe are also used in Ubuntu and are just significantly better than what's available out of the box. And then you add that control framework, and all of this is able to report logs. So if you have any SIEM integration or you need to be able to track, hey, what's going on? I need a notification if anybody gets through. This is all out of the box, available as part of that special interest group. You can run it today. One of the examples of this working is the hardened glibc from the community. You may have heard about Looney Tunables a couple years back. there was actually a very narrow window between when it was reported and when the patches were available. But even those number of days, if you were a vulnerable enterprise, someone could have taken advantage of that. If you had been using this hardened glibc, and this has been tested, that would have outright mitigated their ability to take advantage of Looney Tunables on your system. But if you were running a standard system with standard hardening, you would have been completely vulnerable. So in fact, I am going to show you an example of that because it is much more interesting than listening to me talk. So this is logging into a 9.6 box from last year. Run the CVE. What you'll find is due to some of the weakness in existing default settings and the default tools, the attacker is able to exploit the shadow password, and they're able to get the root password. And then this was something that we could have done on any enterprise Linux out of the box, I think about 9 months ago. And there was a period of months in which this just wasn't patched. And it would have been prevented if you had been using the SIG security packages. So you take a look, it's trying to get in. And boop, boop. There you go. Look at that. You got your password hash. Then first step is, okay, the very fact that they can get your password hash is pretty scary. But then you can crack that password. We work at CIQ with Solar Designer, who created John the Ripper back in the 90s. So you go ahead and take that password hash they were able to grab from your shadow and run it against. This is not even very expensive hardware he's running on. He's running on pretty basic hardware. He just runs John the Ripper on that password hash he got, and he's able to get access to that root password. And you can replicate this yourself as well. There's a blog post up on CIQ.com where you can see how this can be done and how it could have been prevented by having the SIG security packages implemented. But don't take my word for it. Yeah, that's where we're running. Takes that hash from earlier, that previous step. There you go. There's your password. Secret 666, full access. This was out there on a default Enterprise Linux, OS for months. So it's just not enough to leave it to basic hardening. So I want to talk to you about Linux Kernel Runtime Guard. Linux Kernel Runtime Guard has been around for a number of years. It was originally by a gentleman who's the director of offensive security at NVIDIA, created a number of years ago. What it does is essentially you stick it into, it gets access to the kernel, and it effectively takes a snapshot of the state of the kernel. And this is particularly tricky because, as you may know, the kernel state is changing constantly. Every time you touch it or do something or just it exists, that's changing constantly. So it has to do a lot of tomfoolery, which I am not able to understand, to identify when the particular state changes are not actually something that were authorized by the user. If it does catch that, however, if it does catch that a state change or a command was submitted that circumvents the natural process, that's generally what happens when a rootkit gets in, then what it does is it will either alert and it just lets you know. Maybe you're using Prometheus or you're using some other tool, or you get notified, hey, someone just got access to your kernel, you should probably do something about it. Or by default, the behavior is it will just shut down your whole system. Much better to have it shut down and not be working than to have someone have access while you wait, to check your notifications and know that there's a problem. And to that effect, I don't want to risk bricking a VM while I am right in front of you. So I'm going to show you what it looks like in production. This is LKRG on a Enterprise Linux 9.1 box because I had to find an exploit that was still out there in the wild. This CVE 2024-1086 is still, there's a proof of concept available where you can run it and it will get you exploit the kernel. And this is with LKRG off.
Is it possible to zoom in?
Yeah, there. Let's see if I can. There we go. Okay. All right, so here you go. LKRG is not on the system. So this is a VM I was just running today, double checked it. We ran the exploit. There's a binary exploit available on GitHub that replicates 2024-1086. It creates everything, it sprays out, and it's able to find the kernel base, and it just overwrote the mod probe. So they have access. They can go do whatever they want. This was patched in a later version, but in the meantime, you were vulnerable. Now, let's see what happens when you do it with Linux kernel runtime guard on. So Linux kernel runtime guard is loaded. We run the same binary exploit, and suddenly, what happens? Well, what it is it bricks the VM. It shuts the whole thing down. So that's the whole part. That's what it does. Is it waits until there's a container escape or a VM escape. Somebody gets access to the kernel, and it detects that there is some change in memory or some unauthorized behavior, and it will either notify you or brick the whole machine. By bricking, I just mean it shuts it down, not that it actually loses your data loss. Not taking responsibility for that. Yes?
What does IR look like after this? Like, does any telemetry or logs get out, or does
Yeah.
it happen before that can happen? Like, are you looking at an offline forensic investigation at that point, or like how do you respond after you've had this?
Everything's logged through a general, through a journal, and it is wired up so it'll come through all of your normal SEIM processes. So you should be getting a log of this, depending on how you have it connected through the whole process. Worst case scenario, once you're able to isolate it and boot it back up, you'll get whatever's left in the journal. But typically, we expect most of this to just come through SEIM naturally. Most of the time, what you're going to find out is you get a notification. You go, oh, something bad happened.
Yeah.
LKRG did something that was probably, you can see over here, in a test that was an objective test by a neutral party, 8 out of 9 rootkits were detected and prevented. Again, it's not perfect. Heck of a lot better than 0 out of 9 rootkits being detected and prevented. And this is active today. Anybody can go grab it, install it on any Enterprise NX9 box. And I highly recommend you do if you're running anything highly secure, because we're only going to see more rootkits these days. There is, if you care about it, a performance impact. Now you can tune it a bit, but we've generally figured that 2.5% performance impact for most people is worth a very significant ability to prevent rootkits kind of across the board. That was actually that demo. Now, one of the challenges is once you bring in these extra packages and these override packages, what they're doing is they are disabling a whole swath of services that you typically don't need and closing down attack vectors you typically don't need. These are tunable because not everybody is going to be able to, there's a trade-off. There's always a trade-off with security. Once you're locking down generic things that we think you should not be using, or that most companies or most users are not using. So you can use with the SIG security, provide control. You can tune which of these settings you have. You can tune the hardening up and down, basically impacting performance and how aggressively you are disabling services and how aggressively you're closing attack vectors. Generally, what we recommend is you start pretty highly tuned and then only tune it down if you run into some of your services or your applications no longer working. Or if you end up finding that your performance hit is just too large. But even with everything significantly hardened, performance tuning kind of generally is about 4 or 5% in our tests at the enterprise grade software. I'm going to drop that. Once again, there are trade-offs. There are always trade-offs when you are hardening a system. And that's something that we talk with a lot of customers about is why doesn't everybody do this? Why doesn't every enterprise distribution or every distribution just come out of the box and have all of these hardening pieces put into place? And it's a trade-off. It's a performance trade-off, especially if your focus is on performance. They're not going to turn these things on by default because, especially for large corporations, 2.5% is millions of dollars in compute every year. If you tune it even further, 5% performance, it's a really, they're maybe looking at it saying, hey, it might be worth getting hacked to not lose that much in compute, especially if they're paying a lot of money for very expensive hardware. The other is the trade-offs from usability. If you have something working and you come in and you apply this hardening, things are probably going to break. But that's a trade-off for doing proper hardening. So generally what we recommend is if you are applying these, you take a dev environment, go turn on, install some of these packages, and then see, hey, have all your stuff running, make sure nothing breaks. If something does break, you can then use a control package and you can choose, modify some of the settings to tune down just how much hardening you have in place. The beauty of it is all of this is open source. So SIG Security is always open. SIG Security is, you go to Rocky Linux Mattermost, and you can talk to the security team at Rocky Linux, ask questions of Solar Designer, who has built or championed a lot of these. Solar Designer is you may know OpenWall or OpenWall Linux from a number of years ago, which is generally considered like one of the most secure Linux distributions that was ever made. And Solar has contributed a lot, and he's always open to talking to people, and he is just a wealth of knowledge. So if you're looking for, hey, how do I apply this to my system, which it's not currently built for, or I'm running into some issue rebuilding this, or you're looking to contribute, they would love to have you come and ask questions and help out. Or just ask questions. They'll love to help you get this running on your system. For some of these, it's not all from Rocky Linux. This all comes generally from the community. Linux kernel runtime guard was contributed to OpenWall, password QC and YesScript, of course, OpenWall. But our hardened malloc that we're using as part of SIG Security, that came from Graphene OS, which you may be familiar with. It's way better than what we had, and it's very useful. So say, hey, slap this in there. It closes off entire attack vectors. And the Rocky Linux community, of course, supports the SIG Security, which we have if you install Rocky Linux, you can very easily run a DNF install Rocky Linux security meta package, and from there you can start swapping out packages with just a DNF command. One thing to note, SIG Security, everything's in the public, and CIQ also puts all of its stuff in GitHub. So we have our own build of Rocky Linux called RLC Pro, Rocky Linux from CIQ Pro. And we have an RLC Pro hardened version, which includes all of these security packages, as well as images that are pre-stigged or pre-hardened with CIS, along with a lot of other goodies like FIPS 140-3 certified modules and long-term supported pinned versions for enterprises that need to stay. Everyone here can go and get that. You can go get a dev license right now and run it on your home lab if you just want to test it and you don't want to do all the stuff of building it yourself and rebuilding all these packages and shoving them into right on top of Rocky Linux. So you can go to ciq.com and grab one of those. The trick with doing it yourself is that there's a lot of testing that needs to be done. Every time we get an update to these packages, what we do is we will test it across a matrix of hardware and test it with certain ISVs, independent software vendors, and IHVs, independent hardware vendors. So we test it across like AMD, NVIDIA, a number of server stacks. We're not doing it generally on like desktop devices. We're more of an enterprise company, so I can't guarantee it's going to work on your framework, but I'm going to go see if framework will loan me a laptop, and then we'll make sure it's part of the matrix. That's my justification for them sending me a laptop, not because I want it. Baby System 76 too. I'm not greedy, a little greedy. Increasingly, however, at the enterprise level, there are certain things that are very difficult for individuals to replicate yourself. Secure Boot is one you may hear about a lot. Getting your own Secure Boot shim signed by Microsoft is a very extensive process. It's not something an individual or even a company is going to do generally. So while you can have these things running yourself, anytime you're modifying, for example, the kernel, you are dealing with, you can't get the same level of Secure Boot signing that a company is going to be able to pursue. Luckily for most of us, we don't care. But it's something to be cognizant of, is while you can do it yourselves, increasingly the direction we're seeing is a lot of these things are being corporatized. So certain things are not possible for individuals. This is not a talk about that, but it's something generally I think we all need to be aware of, especially when looking at things like secure supply chain, SALSA. There's kind of a consolidation on, at the end of the day, somebody, a large corporation, ends up holding the keys. And we just got to be aware of, even as these things are out there in the environment, this is free, it's software that is open source. the folks are finding ways to lock down part of the build process or certain parts of the process to make it possible to deploy these on your hardware that they can kind of find ways to get around GPL v2. So that's kind of a red flag for anybody if you want to dig deeper into kind of where things are going at an enterprise level. We want to be able to keep control over what we deploy on our stacks. That's why everything CIQ does, like all the changes we make to Rocky Linux, all our LTS patches, all our FIPS patches, you don't have to sign up for anything. You can go to GitHub. It's all public. It's all right there. And we want to keep as much of this as possible out there in the open. If you want to go install any of these yourself or play with it, again, I recommend going to Rocky Linux Security Special Interest Group. They make it really easy to install. If you have questions, you can go check out the Linux Kernel Runtime Guard source code for this demonstration earlier. I grabbed it, I rebuilt it for 9.1. It was very quick because the latest version you grab from Rocky Linux is for 9.7. They didn't have one for 9.1. Super easy to build. OpenWall, if you want to know what's pretty cutting edge in terms of security, I would check out OpenWall, maybe check out their mailing list. There's a lot of fun stuff there. By fun, I mean terrifying. And then if you don't want to do any of it yourself and you want just grab our version that's already pre-built and turnkey gold image, please head to portal.ciq.com, sign up for an account, grab a developer license, and you can be testing it in 10 minutes. Any questions? Yes, sir.
It seems like there's a growing trend in some Linux distributions to address most memory-related problems by rewriting, critical software with Rust. I think Ubuntu is doing that.
Yes.
They even started to rewrite, the GNU bin tools, utils. So what's your take on that approach?
I'm very happy that someone is doing it. I am going to very much appreciate that they are doing it. I will sit back and watch and see what happens. And I'm going to continue using things that are written in C for the next couple of years as they figure out the growing pains of making Rust the base and default for a lot of that. I think it's something that needs to be done to have an alternative to C. I think C still is really, really good and really important. And Rust is not an answer to everything or all memory problems either. But that doesn't mean it's not it could be the better way. I don't think it's, or at least my understanding, and talking to people way smarter than me in the space who have been working on this for a very long time, is it's just not a silver bullet. It is better in some ways and it's worse in others, and you're giving up some level of control. So I hope for the best, and if it turns out to be better, we're all going to move to it. Not quickly, but we'll all move to it if it proves out to be better, but someone had to do it. And Canonical going out and just taking the plunge, otherwise no one, it would just stay a hobby at that point, or a theoretical.
So it seems like a lot of these mitigations are primarily focused on kernel level stuff. How does user land level exploits and stuff factor into a lot of these mitigations?
Well, yeah, and that's a good point. I think part of our focus is that a lot of the exploits, a lot of the security out there is already focused on the userland. A lot of our focus has been on what happens when someone already gets access. What happens if they already get the rootkit is already there? Because there's not a lot of answers at that point. Everything's about, well, we'll patch that vulnerability or we'll try to prevent it outright. But if you don't, there's no guard. The guard's at the front door. There's nobody in the building. There's no cameras in the building. And so that's what Linux Kernel Runtime Guard is. And then they're with hardened malloc and hardened glibc, that's more user space, just identifying broad attack vectors that by default are not handled. But password QC and YesScript I think are more user space. That's the more user space focus around the default password options that come with. Actually, I think what's the number? I think I'll see if I can find it on one of these slides. I may have dropped it because it seemed too crazy. Yeah, I think I dropped it. But with password QC and YesScript, it is actually, you know what? I think I may be able to show you. Let's do it. Okay, so the difference between your standard password checker is you put in a password. If you run Enterprise Linux right now and you use password as your password, that's fine. If you switch over to password QC, it's gonna be requiring you to have a much more rigorous password. So password QC and YesScript both have a much more rigorous dictionary of passwords that are allowed, while still simultaneously being a better user experience because it's not blocking just passwords that are secure but have arbitrary like regex. But furthermore, between YesScript and password QC, it can be 20% harder to crack the hash. And it's just a significant improvement overall, and we recommend people switch to it. I think that's why Canonical did. And then these are more dummy scenarios, but with YesScript, I'll see if you can see. The encrypt method is significantly more robust. I can't get it open. But I also recommend checking out on CIQ.com. We have a blog where we go into detail about just how much more robust and how much more effort it is for a person to crack it once they get a hold of your hash. And that's kind of the belief is at some point they're going to get a hold of your hash. The best thing you can do is encourage users to have better passwords. And then when they do get a hold of the hash, inevitably just make it harder. Although with quantum computing. Yeah. Any other questions I can answer? Yes, sir?
So my question is kind of like, I wanted to look at the history of security. If we go back to the PDP age, the manufacturers like DEC worked tightly with their own software, and so they worked on security holistically. And back then there wasn't much networking and internetworking of computers, but that followed. But then the big separation happened with x86. The processes went one way and the operating systems went a different way, and they were completely different entities. And then recently they've come back together with the iPhone. Apple's got a tight control of because the hardware is very miniaturized, they have control of essentially the Linux. So my question is, if we come back to the server side now, back to bigger machines, are we going to see signing of the hardware at a detailed level and with integration with Linux?
That is a big topic. One of the things that's been called out that I've heard recently is just how much there is a separation of the OS and how small of a piece of a PC, of a server, of a computer, the operating system actually runs on these days. We as users interacting with Linux are actually only seeing a slice of the overall system. All of these different components are essentially running their own miniature operating systems and their own miniature environments, which we as users never see. And those are from different manufacturers, and you just hope that they talk well together. But they really only care that the hardware works. They're not speaking holistically or looking at holistically. They're saying my little piece of this puzzle, my NIC or my GPU or my DPU, it has its own stuff and it works and the API works and so we can communicate. But beyond that, I don't care what you're doing. I'm going to protect my piece of this PC, and I'm going to use legal protections, and I'm going to use physical protections to lock you out of it so you can't see my secret sauce. I would worry generally that we're going to keep going the other way for a while, that there's going to be more separation in the device as the people are able to put more powerful software on each device, and each device is going to be even more individualized and siloed. I don't know what the consequence of that is, but it really makes the definition of what an operating system is kind of start questioning, what is the operating system? Now, it's your amusement park human to be over here while we, the computer, does the real work elsewhere with our own little environments. I think where you do see forced integration is confidential computing. So when we look at multi-tenancy at scale for clouds, what they're looking at is I'm just bought this really big GPU server, and I'm going to sell slices of it. but I need to make sure that you and you and you and you are, even though you're running like in containers on this same slice of the GPU, you can't see what each other's doing because you're taking your very sensitive data and running it into a slice of the GPU. And by default, the GPUs were never designed to keep that information separate. So confidential computing is a kind of it's a forcing function where we have to ensure that there is attestation and provenance for separation of concerns, so that when we are running on the same GPU, we're not able to see each other's data. But that requires a chain of trust because right now we have really good encryption for data at rest. We have really good encryption for data in transit. We have almost nothing for data that is running, like in memory or on the GPU. And that's where a lot of work is going for the CPU vendors. So AMD, Intel, they are pushing out things like AMD SEV-SNP and Intel TDX. And then they're working with NVIDIA and AMD, and AMD is really ahead on this, to ensure that there's integration between the CPUs, like isolation, and the GPU isolation. Because this is a really, really big deal to ensure that if we were going to keep going this direction where everybody's just sharing space on some big GPU in the cloud, we're actually able to have comfort and confidence that a bad actor, not just like each other running, but even someone at the company who has direct access can't read that data. And that's where you're going to see more people talk about that as that actually gets deployed. It's still really tip of tree for the full implementation, but it's a big thing with like the CNCF, cloud native. Don't remember what it actually means, but that's the type of forcing function that's going to bring people back in and corporate enterprises back in to have to work holistically to ensure that that chain of trust is in place.
Thank you.
Mine is, question is, as you've seen the special industry for security, how much of that is being picked up and being part of the defaults? Because the tyranny of the defaults is really strong.
Yeah. I don't see them being picked up by defaults. For Rocky Linux specifically, and I can only really speak to Rocky Linux is opinionated in that it doesn't have an opinion. Rocky Linux is a straight rebuild of Red Hat, and it's going to stay a straight rebuild of Red Hat because no one else is a straight rebuild of Red Hat. And that's its whole thing, is to be bug for bug, to be binary compatible. I'd say if anyone was going to pick it up, I'd say like a distro like Alma Linux would be more likely to pick it up because they are opinionated about diverging from what Red Hat does, because if they feel that there's a better way, they will absolutely, or the community will decide to add it. I'd say that if there are some of the more security-focused distributions might incorporate it. For us, we strongly believe, CIQ strongly believe in LKRG and the rest of the security stack, so we're going to keep contributing to it and encouraging it. And Solar Designer, who's the lead on that, is out giving talks. And so we're starting to see more people take interest. I would expect LKRG or alternatives to it to eventually become a default down the road, but I think it's going to take years because right now every vendor is they're more afraid of affecting performance when you're running an NVIDIA GPU than they are afraid of you getting hacked. So it's going to stay a customer decision for a while. That's the death knell. If you walk up to an enterprise and say, hey, I'm taking 2.5% of your performance, they're just going to walk around. It takes a very special customer to be willing to make that trade-off. Especially if I go to Phoronix and I'm seeing, oh, this is worse, out of the running. Yep.
Is the performance impact just like limited to the CPU? Like, what is the?
Interesting question. No, actually, we did an analysis, and it's not all workloads. 2.5% is a gross reductionism. It's gross generalization. There are absolutely workloads where it doesn't impact it at all. So this is just kind of high level. There are workloads where it impacts it more. If you follow up, I can get you information on where. I'd have to go dig up what that last analysis was. But we're just saying broad brush 2.5%.
Gotcha. But I guess is it in terms of resources, is it will it eventually be clock cycles, memory usage, is it GPU,
It's all the CPI. It's all kernel level syscalls and lag, because it has to take a snapshot and then check to see whether the change was violating its own snapshot, frame of reference. Yeah. Like, you know where to find me, but I think don't take my word for it. Go grab it, spin up a VM tonight, and then go try to find an exploit and bang against it. Thank you very much. I like your hat. I'm going to keep saying it because it's a great hat. Thank you. I think you got somebody else coming after me?
Yep, you are all good to go.
Typically, how long does it take to process? A couple. I think the last time was like a week or two.
That is a good question. This is my first year. I'm not sure. It'll probably be pretty similar to last year, though.
Sweet. Thank you for everything you do.
Yeah, of course. Thank you.
Like a AV crew or something.
So
help
I
him
don't remember
with the
which. We did a
presentation.
blog post where we walked
Sorry, what was that?
Oh well, I'm the next presenter.
Oh yeah, I can get you all set up.
Okay, cool.
I'm gonna have to ask Sarah to actually give me the raw data because I don't think we ever published the raw impact of it.
Yep. So we've got a whole thing here, making sure it's streaming and recording and everything.
Okay, cool.
And then, do you have an HDMI or USB-C?
HDMI.
You can wrap it around to the other side.
Cool.
The Veronix test results for LKRD. I'll make it difference too.
Would it be particularly difficult to run the test suite ourselves?
Absolutely.
See what it's looked like on our
That would be my first recommendation.
Somewhere to plug in power.
But I think it depends on what hardware you're running on.
Oh, there we go.
Yep, that's perfect right over there.
Time on a decently powerful machine, get some different cross cut. And you may already have a bunch of data from multiple pieces of hardware.
Perfect timing.
I should be running it every time you do an update and sharing. I'm happy to get release notes.
Okay.
Thank you.
So I got a mess with a bunch of stories, so it's next time, so it's really easy to try to undo it.
Right. Oh, it's broken. Oh well. Yep. Reproducible builds. Thank you for all your work. That's great. Someday, one day I'll make it happen.
Well, you want to stay from the top. Literally in favorites game.
I abandoned my friends after I do appreciate it. I'm very glad I got the traffic seat. I'm still trying to convince people that we need to make reproducible builds a thing. I'm like, let's make sure we have,
Is this okay?
Oh yeah, totally.
Okay.
It's not currently the top priority for the team. I think it's going to take more time to advocate for it. I think right now there's a lot more pressure. Unfortunately, I think we talked about SALSA and attestation and provenance, which by definition, what gets observed gets changed. I don't remember if we figured out where the overlap would be or conflict between a build being reproducible versus a build that has attestation and provenance, because you are taking a snapshot of this build at this time and blah, blah, blah. And at that point, it's not reproducible because you have that definition, that timestamp of when it was built.
Yes, I think you did talk about that because that gets embedded in the RPM, as I understand it. So the RPM.
Oh, it got it backwards.
So
Oh
if you,
dear.
If you have that, is it truly reproducible, or is there like?
So if it's on the extend one, if
Yeah,
you
yeah.
minimize it or make it smaller, you might have to drag it
This
over.
the program I'm using should figure out which is the external and which is the internal display. But it got it backwards and I just have to tell it and oh.
It's got captions going.
Right. Okay, so what if
Looks like it's seeing your terminal.
yeah, it's seeing my terminal, but
to have that
that's issue.
all the way up.
Could it not be separate?
Something is not going right here.
Oh, no.
Oh, great.
Just set the
That's
time
gonna go
to-
well.
So always be minus one or something.
Like feed in the time as a parameter and have it output with that
Oh,
timestamp.
let's see,
The-
that
And
is
then that,
2.
the checksum would be the same.
The trick
Wow.
is, and I'm looking at Alma and the way they're doing this, because they have an SBOM for every single package that gets built, which is awesome. There's a lot of work to do that.
Yeah.
But if it's the same checksum and you build the same package 2 months, like one in January, one in February, then you've got 2 different SBOMs. Which SBOM goes to which package? Because there's some of the questions around salsa is also like, where was it built? Who had
Okay,
access to it?
so now I
Was
just.
it in a secure enclave? So there's additional
Where's
rigor
my
around
screen? There we go.
that no one, not even an internal user, had access to the enclave when that was
Let's
built.
see, I
And
think it
what
had
went
an
in is exactly
option to
what
just
went in. And I think that by
switch.
definition is like antithetical to the reproducible builds.
Yes.
Well, not necessarily, because all of
Switch
this,
screens. Okay, let's try that.
metadata and signatures and stuff like that, if it's detached from the binary artifact, then you're gravy, because then the binary artifact will always have the same.
Come on.
If you build it, but then all of this extra.
And what's really weird is it's not letting
We
me
need more
do
information.
it. Oh, because it's the presenter screen. Okay.
Like in the way that a GPG creates like
Let's
detached
see
signatures
here.
and the RPM model is essentially inline all of that data. But it requires like a reworking of how.
That's bizarre. I've never had this happen before. Let's
If it's just
do.
one file, you just throw it around, that's super handy.
Alright.
So you can take the same source
So-
code and you can build the same RPM on a different piece of hardware, and it's going to, there will be edge cases where it behaves differently.
Let's try
and
this again.
I'm actually, that's one question I've had about reproducible builds, is how do you handle those edge cases? I never ran into them, I've only heard about them in stories and legends, but my understanding is technically feasible. And hence it doesn't. Where if you build that same source code on different machines, you're going to have potential edge cases where that one binary works and one binary does not, because of just absolute like randomness of flagging position of.
What if?
I don't know how often that is an issue these days. But,
It's not as big as issue. I mean, they're certainly.
Let's see. Force to one screen. Alright, let's do.
A lot of those things can just be got rid of by building in on like 2 separate infrastructures, but like both of them you control and online like.
So it's got EDP1 and DP1. Okay, let's see if I can.
This is why I'm so curious about reproducible builds, because the promise is it doesn't matter if you were in a secure enclave or not. Although that, I guess that does predicate, you're presuming the first build
Presenter screen.
was safe. So that if I rebuild it and match that first build.
Well, not necessarily. I mean, you could just arbitrarily have like 100 builds. And, like, it doesn't matter what you build in it. But if the consensus, like, the consensus converges to one particular result.
We all built XC.
I mean,
nobody solves that.
Yeah.
Nobody solves that.
We all build
Whoops,
XC.
that's the wrong
Nobody. We all build XC. Nobody solves that problem. If it's in the source code, near.
Monitor 0 now.
Yeah.
What? Okay, well, that explains some things.
So what release source code?
Oh, it was.
We said-
I thought it was only.
But with obfuscation, so you
What?
wouldn't really see.
Oh boy.
And it would only come up in some binaries. So when it gets reported, it's like, oh, it's only in the.
Let's try this.
Oh, okay.
But that's because, you know, they have a big if Debian switch. Isn't possible to read.
So it was only in some binaries because of a conditional.
This is the
calculation.
first
Is there a
time
way
I've
to
ever had this
switch
happen.
to mirror instead of extend?
Oh,
Which is another way to do
wow.
it. 'Cause then you,
So
oh, it's the
sometimes
binary.
that's
It's
been
like,
an
yeah, no,
issue.
Yeah.
That explains why it was quite so scary.
Yeah.
I'm really confused why
Could
these
be.
binaries were so far.
Oh
like
boy,
that.
10 minutes. This has always worked for me before. Why is this being?
I'm observing.
Can you even do anything? Because like if you're doing the one-for-one rebuild of Red Hat, like,
So
is there enough control?
For Rocky Linux, we have to, the debranding has to happen. The trademark is, depending on which lawyer you ask, the only thing that's actually.
We're just
What
trying to
if?
figure out how to get the right screen to go up on
Otherwise,
there.
in theory,
So it's
those are
showing
the
his
only
terminal,
changes.
but not his
In
presentation.
practice, there are occasionally
Interesting.
differences because we use different build tools.
I don't think it's anything on our end, but.
Yeah, no,
No,
it's
it's definitely
on
a
my
year-end thing.
And the application I usually use that handles it is just like ignoring everything I tell it.
Are you wanting the application to be the only thing on your screen, or are you wanting the two-screen?
Well, the application has one view for this screen and then a different view for that screen, which
Okay.
is why it's nice.
That's what we want up there.
Yeah. That's nice. Okay, well, worst case, we don't do that. Alright, so I need to fill that.
That means you're gonna have to have your customers all using the same version of Linux. There's a library that will be different and it will break the checksum between what you're delivering and what they're expecting, right?
For us, yes, but if they're.
Okay, so other option is to just do it this way.
Some exceptions.
I'm thinking Debbie, if you're going to.
That's a much bigger
There
divergence.
we go. That's some option. Let's try this. Okay. Oh, wait, that's
Okay.
That worked?
sort of, except I don't have the other screen. Where's the presenter screen? It's probably on this display
Sounds like a
somewhere.
restaurant, you know.
Alright, I have another idea. Interesting.
Very interesting.
Where is this?
Do you have that session you're supposed to do?
No.
No? Okay. Nope.
Maybe one.
Oh, and then the USB-C adapter, I couldn't find the
Yes.
bag for it, so I just put the adapter in the box.
That's probably fine.
Yeah. Oh wait, I think I might have just found it actually. Yep, found it.
Awesome.
I just had to say it.
It refuses to do what I tell it.
It's amazing how 50% of problems just solve themselves as soon as you tell somebody.
Yeah.
Alright. So, that's what I want. Is it got it backwards somehow? What is it? 2, 3. Where's the presentation console? Can't even see the screen. Okay, well, that's no good. Huh. Curious. If I do it here. Yep. It's refusing. Ah. Still have some time. Oh, that explains some things. Okay. That gives me an idea. There we go. This might work better. Okay. This looks much better. Okay, cool. There we go.
Figured out?
Yep.
Nice.
Perfect.
At least.
Alright, well, I'll head out. I'll let you guys.
Okay.
We'll listen to speed behind you.
Thank you, Rachel.
Yeah, of course.
Alright. There we go. I'll let the timer reset. Cool.
Alright.
Wow. A little bit of scrambling, but
Yeah. Quarter yelling at me on the Discord. Okay. Would you like to introduce yourself to the group, or would you like me to introduce you?
Either way.
And that's why I'm asking your preference.
Sure. I can just introduce myself.
Okay. That works for me. I just have to keep it like eye on how full the room is.
Yeah. Oh, right.
So, those are good there, those are good there, those are good there, and I've got the things I'm supposed to see there. So, tech stuff is good.
How's the mic? Just talk? I don't need to be any...
Yeah, it should be omnidirectional and just
Okay.
able to pick up your voice.
So
you
it can even
see
move around a bit and stuff.
Yeah, it's captioning. The
Right.
caption service is not great.
Sure.
But the mic still hears you.
Yeah. Okay. That's good to know. using it. Or is it close enough?
Yep.
Okay.
Yep. Go ahead.
All right. Hi, my name is Vagrant Cascadian. I'm here to present on behalf of the Reproducible Builds project. The topic is Beyond Trusting Open Source Software. This is my first time making it to Linux Fest Northwest. I've been trying to make it to this conference for probably almost twice as long as I've been working on Reproducible Builds, which I've been doing that a while. I've been using Debian since like 2001, and around 2010 I officially became a Debian developer, but I started working on a project in the Reproducible Builds project in 2015. So that's over a decade now. I've been doing this stuff a while in one capacity or another. So I like to think of free and open source software. One of the most important things, you got to be able to use it. You have to be able to study it. So you have to have access to the source code. You have to be able to change it so that you can change it and share your changes with the larger community. So this is a pretty basic concept. I'm guessing most of you have a handle on these things. So I'm not going to go on at length about it, but it'll come to be important. So what does source code look like? This is just a little snippet from part of the Bash 5 source code from way back when. You can see some functions and you pass some stuff to it, and while it may not be plain language, it's all pretty much human readable in a sense. You might have to have some specialized skills in order to read it, but it's letters you might recognize if you're familiar with Western alphabets and so on. The process for transforming that into what a computer actually uses might be your classic configure, make, install. A lot of stuff happens inside of this process, and the end result is something that looks a little bit like this, which while there are ostensibly Western letters and whatnot mixed in there, and maybe you can make some tiny sense out of this, chances are you're not going to be able to look at this and have a real understanding of what it actually does. Typically, a process of turning source code, which is kind of a human interface to tell the computer what to do, into binary code, there's a bunch of steps in between there that happen. And things can go wrong there. And we've actually seen some attacks where people have meddled with the steps in between those 2 points. And so the really important thing, and why reproducible builds is important, is it provides fairly high confidence that the binary you're actually running on your computer was produced from the source code that you can actually look at and do your security audits on, and that those in-between processes, the make, which might call out to a compiler, or it might read your text formatted documentation and output a PDF, or it's not all just binaries per se, but you have a number of processes there. You output your binaries, and so what we're working on with reproducible builds is we want it's this crazy idea that when you build something and then you build it again, it comes out identical. Not just performing similarly, not just just identical, because that's the simplest way you can tell. You can just compare it bit for bit. You can use some checksums, and you can get a high confidence that, okay, if I built that here, somebody else goes and builds it, they get a bit for bit identical result. You have a high confidence you're working with the same binaries at that point. And you know the source code that you can go back and look to make changes and update it. So that's really useful. That's really important for a security audit. It's we don't really know for sure that the binaries we're running are from the source code, but let's go audit the source code. But somewhere in the middle there, you could have a compromised compiler, the build server could be compromised, even crazy stuff like, you know, just a stray bit flip from like some cosmic radiation just hit things at the wrong moment. You end up with a different result, right? So like even with no like malicious actions involved, sometimes things go wrong, and reproducible builds is one of the best ways to identify some of that stuff. So I mostly got involved through reproducible builds with the Debian project. And Debian claims to be the universal operating system, whatever that's worth. But you know, I'll just describe a bit how it's universal in the sense that it has tens of thousands of source packages. So it's got a lot of what is available in the free software universe, in a sense. Yeah, it might be missing something here or there or whatever, but it represents a large slice of what's available in free and open source software. And this number is already out of date since I built the slides. Similarly, you know, 380 million lines of code. So that's a lot, and I think this number is from like a couple of years ago or something. So that's why we say it keeps growing. We have managed, as the Reproducible Build Project, to, by and large, make 96% of it reproducible. So that's a large part of a large swath of the available free software available to anybody. You know, Fedora has most of those same, you know, tens of thousands of source packages, most of the same lines of code, maybe slightly different versions or whatever, but proof of concept, it can be done. Granted, that remaining 4%, there are probably some kind of key, critical, important bits. But, and so last mile problems and all, or if you prefer, last kilometer problems. So there's still a lot of work to do. But we've proven that this is not impossible, right? You do 96% of you know, close to 400 million lines of source code, and you make it reproducible. It's not inconceivable. This is not some like pie in the sky project. So what are the things that make things unreproducible? 80, maybe even 90% of it comes down to timestamps. Developers historically, for whatever reason, they just loved to embed timestamps in their binaries. I mean, some of these projects got their feet in the ground before we had things like revision control systems or whatever. So, yeah, okay, maybe the build time is important in your binary, but these days, I'll make the case we have better ways of tracking, like, your build environment. Like, when this was built doesn't necessarily matter. You can build the same source code one day, you build it the next day. Should still come out the same if you're not changing the source code or your tool chains or anything like that. So timestamps are one of the most obvious, easy to wrap your head around ideas of if you're embedding the timestamp, you run a build yesterday, you run a build tomorrow, probably going to come out different. So we're trying to root out a lot of those sources of timestamps. Sometimes they get unintentionally added as a result of tool chains. Sometimes people intentionally add them, and so we try to submit patches upstream to get them to fix those issues. In my opinion, there's no timestamp better than no timestamp at all. But we have some options for the people who have a middle ground take on it. User information will get embedded in the environment. So like, you know, if my username, I typically use Vagrant on my build machines. You probably don't use Vagrant as your username. Sometimes that'll get embedded into the build environment. So things like that. Things like building on a common build infrastructure where you can normalize these things can help work with those kinds of problems. But then you even get into like host system information, like the running kernel version often gets embedded into stuff. Again, I feel like we have better ways of tracking this stuff in the modern era, and you lose a lot by missing out on reproducible builds. So there's also just some projects where it's just random stuff, you know, injected in there. Sometimes that's intentional. Sometimes some crypto libraries will, I mean crypto in the traditional sense. They will inject randomness in there as part of their test suites, and they want to ship the test suites so you can run it on the installed binaries or whatever. There are cases where randomness makes sense, but Oftentimes you can get around that by doing a deterministic seed for your random number generator, because when you're distributing binaries, having a different everybody uses the same randomized binary, you're not really getting much benefit out of that randomness. So there are many, many more things. The weirdest one I think I ever encountered was where this one binary was coming out different only when you ran it in an environment where the locale was set to Italian. I tried Korean, I tried Chinese, I tried various Arabic languages, but Italian was the only one. And the reason is the output of the LD command translated as I think it would, on English or C or whatever locale, it would be GNU LD. And in Italian, somebody had decided to translate it and translate it as LD de GNU. And sure enough, Italian was a unique case where, so those things you can kind of normalize, typically if you're running in a build farm, you might want to normalize, make sure your locale settings are consistent. But that was one of the weirdest ones I encountered. Surely. But really, timestamps. Get rid of those timestamps. I can't stress this one enough because it's a huge problem. It's always going to be a problem. It's hard to normalize. But some people are really attached to their timestamps, so we have an option for you. So we developed a specification called source date epoch. Basically, you specify an environment variable, which has its downsides, don't get me wrong. But it's specified as the second since 1970. Our specification says tools, when wanting to put a date in for whatever reason, this is the date you should use. So that's a way to normalize that, and then in Debian we pull it from the latest changelog entry, and then we set the value to that so that it's somewhat reasonable. It's supported in a number of compilers, including some of the core ones like GCC and Clang and whatnot. So this is a way to kind of meet in the middle, but you get some weird things. I'm pretty sure Nix and GNU Geeks will set this value to 1. So 1 second since 1970. So you'll get a lot of man pages for things where it'll say this man page was updated in, January 1st, 1970 for programs that hadn't been invented for decades later. So there are some weirdnesses to this, and that's why I really want to stress, there's no timestamp better than no timestamp. So anywhere you can, try and avoid using it, but as a workaround, some people are really attached to it, so you can pull, you could use the latest revision from your Git history, for example, is another pretty reasonable thing to use for source date epoch, or from some sort of changelog entry, or something that's a more reasonable date than when I happened to run this build. This is the last modification of the source code, basically, is the summary of what source date epoch is trying to represent. So we have all sorts of, so when you want to do a reproducible build, you have to have certain information. You need to record exactly which version of which tool did I use to build this. So you want to include things like that. You want to include what value you ended up using for source date epoch, because you can pick a pretty arbitrary value. So that needs to be known. And it truly works best with free and open source software. While in theory you could, as a proprietary vendor, do reproducible builds, the independent verification is really important, and you can't really do independent verification unless you have the source code. You could set up an NDA or something, an arrangement with some third party to vet it, but then they're going to be biased towards providing you the answers you want, not the answers you need. Truly, I find this works. Free and open source software is really a crucial feature that free software can provide. Well, free software can access reproducible builds in the truest sense of the word to provide the greatest level of independence. And also, obviously, if you've done any software development, you know things break when things change. So we have regressions. I mean, we've gotten to 96%, but honestly, we've been hovering in the 90 to 95% for ages. And, you know, sometimes that number goes up, sometimes it goes down, it wanders. So you gotta constantly test this stuff. And simplest thing to do is run a build, run it again. I mean, if you want to get really fancy, you can run a build and then run it on another machine with a slightly different CPU vendor, like an AMD versus an Intel CPU chip, as you know, just one example. You know, machines with slightly different amounts of RAM, maybe that's running the older long-term support release kernel and ones that's running the latest kernel, things like that. But yeah, it's setting up CI environments to run multiple builds, ideally in as diverse of an environment as you can really help finding these things early before you end up releasing this stuff. A tool, it's a little bit poorly maintained, but we developed a tool, it's written in Python, and it basically will build something 2 or even more times with variations. Like, it'll change all sorts of things. Like, it'll emulate the kernel version, it'll enable ASLR, it just like does some things, and it'll at the end it'll display the differences between your 2 builds, 2 or more builds in some cases. And that's available at, currently it's still on the Debian code hosting platform. We were vaguely talking about possibly switching to another platform at some point because it's not a Debian specific project. And it also has a really cool feature where it can go through and systematically test, well, is it locale related? Is it a time related thing? Is it this? And it'll go through and, you know, it'll normalize everything, do a build, normalize everything, do a build, normalize everything again, and then it can go through and systematically test what kind of issue this might be. But as I said, it's starving for maintenance. A tool that gets some great maintenance by somebody actually in the room who is not me is Diffoscope. This is like often called a diff on steroids. So it'll go through and you get say like a Java code or something, which is really just a zip file, which is really just a bunch of text files embedded, and you might have them even possibly recursive, if I'm remembering correctly, where you might have another zip file embedded in there somewhere. So it'll go through and unpack all those things and then try and render it in as human readable format as possible, given the huge suite of dependencies that you may or may not have installed that Diffoscope will call out to. So it can kind of locate and highlight some of the issue, you know, where exactly in these objects, these artifacts, because it may not necessarily be, you know, actual binary code or anything. It's supported on numerous distributions out of the box. It's also, I believe, on PyPy, if I'm remembering correctly. Yeah, so, oops, did I back up a little? Here we go. Yeah, and here's just some example output. I think this was an example on some old PDF or something, and it's got like, you know, comparing one version against the next. I know there's a kernel developer I know who uses it to kind of test when he's refactoring stuff. He can like do diffs and see if the refactor, you know, if it changed only what he intended to change or if it actually changed other things by mistake. So it can output in like various HTML formats, plain text formats. And as I said earlier, it has a lot of optional dependencies. This slide is 10 years old. I don't really have room for all the ones we've added since then, but it's been a few. So it supports all sorts of different file formats, which means if you want to test those file formats, sometimes you might have to run your Diffoscope, and then it'll tell you, oh, you should probably install this tool, because you need support for in order to render, I don't know, Microsoft Word files or something. I don't know, whatever. It supports all sorts of different kinds of files. And as I said, it just recursively goes through and unpacks things. Like if you have an ISO image, on your ISO image, you've got a PDF file, and inside your PDF file is like a JPEG file, and and that JPEG file, I think it even has support for showing this kind of animated diff of the different JPEG stuff. So it's got some really cool features. And I tested that this works too. There's an online version of it where you can just upload 2 files and then see what the output looks like. And I even tested it earlier today, and it was actually working. I haven't presented this at other conferences where it wasn't working at the time. Really what you get with reproducible builds, you get a very strong attestation that a binary was produced from a given bit of source, with the right tool chains and so on. Probably. It doesn't end there. There's different levels of trust in this world, right? You can just download stuff and run it off the internet, right? That's very trusting. You can do like Rust does and recommend you just download stuff off the internet, but use security and then just blindly run it. You can download files and verify signatures if you can figure out actually how to get a trust path to those signatures. You can download the source, verify the signatures, and just build it from source yourself, because obviously your machine is pure. You could do that for your entire machine. I believe this is from an example from the Gentoo of just rebuilding all of the parts of their machine. Could just rewrite everything. I mean, just something simple like a little simple assembly to do all your computing needs. Could just why stop at software? We can build it up at hardware. And if you've got a lot of time on your hands and abundant resources, you could just build your hardware. And then it doesn't take long, and we're starting to talk about compromised molecules and stuff. Why I'm talking about trust is Ken Thompson back in '84 gave this presentation about how you can't really trust people who develop compilers. So he basically proved that he can inject a virus into the compiler so that it'll inject itself into future compilers, and then you rebuild the compiler with the compiler, and you can't really usefully audit the source code because the compiler is injecting things. And this is one of the things that reproducible builds is trying to help with, and there really hasn't been a lot of work on solving this problem. And this is from '84, but I'm telling you, he gave his presentation in '84, and he was citing research from 10 years earlier. So we're talking about a 50-year-old fundamental security problem that we're just on the cusp of solving. So bootstrappable is bootstrappability is a concept where typically when you compile your compiler, you compile your C compiler with another C compiler. What do you compile that C compiler with? Another C compiler. What do you compile? And you go on and on and on. And there are a lot of languages these days where they really aggressively, they're like, I've got this cool language and I want to write my compiler for that language in the language itself. And you start to get into some pretty complicated bootstrapping issues, such as, my favorite example, Rust. Rust 1.95 needs
1.94.
Yeah, and what's the next one?
1.93.
There we go, etc. But there's this cool project called mRustC. They worked to, I think it's C++ based, for better or worse. But they kind of cut the chain. But Rust 154 all the way up to Rust 195 is still a lot. So to really get a current Rust stack, you have to build a lot of versions of Rust if you really want to vet the source. Written in C++. But I just learned the other day when I was updating these slides, the recent versions of mRustC can bootstrap all the way up to 190. I haven't vetted it myself, but it is in theory possible. They claim it's possible. And this stuff is important. David A. Wheeler gave a really awesome, I don't know if it was his doctoral thesis or whatever, but he gave a very academic paper on fully countering trusting trust by using diverse double compilation. And this is where reproducible builds comes in, because it's part of the solution. So if you take one compiler and another compiler, and you take the same source code and you independently build that source code through completely different compilers, ideally the most different you can find, and then you get another compiler out of that. If it's bit for bit identical, you have reasonably high confidence that they have not been compromised in the same way. I'm probably glazing over the greater details of it, but that's the basic gist, the important gist of that. And so, there's this project called GNU Mess. It's a scheme interpreter and a C compiler, and it's used for bootstrapping, in particular GNU Geeks. I think there's also work for using it in order to bootstrap Nix.
Is that running Bash?
No, it's scheme based. So.
Well, wait, how do you run Scheme though?
Yeah, this is a good question.
Like all roads
So,
SH, right?
not quite. So basically, this is like a very simple C compiler written in a scheme language. It is slow. But a bunch of us got together, and 3 different distributions, Debian developer, a Geeks developer, and I think it was a Nix developer, if I remember correctly. We all independently built the same bit-for-bit identical using different GCC versions, different libc versions, different operating systems. But it's kind of a weak one because they're all Linux-based, they're all GCC, even though they're different versions, yada, yada, yada. But still, we did the first actual real-world example of bit-for-bit reproduction of a core tool chain used. And so Geeks has used this to reduce the amount of binary seeds in order to bootstrap the entire operating system. So they reduced it down from 250 megabytes to 145 megabytes. But, using Mess and Guile kind of orchestrates it rather than Shell. You could do it in Shell. And you build from source, GCC, binutils, glibc, etc. And from there you can kind of build a fully modern distribution. But 145 megabytes is still a lot of binary code to audit. I mean, one would say it's still ridiculous. So, didn't stop there. So then there's this other amazing project called Hex Zero. The one that Geeks is using is a 357-byte binary of basically, hex assembly. That's starting to get into the realm of something you could actually read. It has lots of comments. That's not included in the byte count. But it has lots of comments about what each line is doing, so they could mislead you with the comments about what it's actually doing. And more recent versions of Hex Zero, I think it's below 200 bytes at this point. So that's like the root of what we're building. And then it builds out a slightly more complicated hex assembler. And another one. And then I don't even know what an M0 is, but that's part of the thing. And then it has like a simple CC to run on x86, which runs another, I don't know, I think they call this a transpiler. There's like some bunch of tools to run like simplified versions of shell stuff. And then we get to build Mess, which is the thing we diversely verified. Not as diverse as we could. Which eventually you build out to tiny CC. At the time, I think it was patched, but I think there's been work to use an unpatched version. And you end up with really old versions of GCC, binutils, gzip, blah, 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 and you use that to build out to newer versions. So at any point in this chain, if people can independently recreate some of this stuff, basically you can with a reasonably high degree of confidence, because I'm not one to really say we've solved it, but a reasonably high confidence that we've avoided the trusted trust problem. Yeah. Then there's another cool project called Live Bootstrap where they do this kind of thing from a live environment. So, there's like no state really. So you can, and, kernel, you have a kernel, some source code. You boot up into a reproducibly bootstrapped toolchain using a very similar path to what Geeks was doing. They also do things like they strip out all the pre-generated source code. So a lot of things like running auto tools or AutoComp or whatever, they'll be like pre-generated ones. And usually when you're bootstrapping, it's like, oh, it's going to be too much work to build those. But if you ever heard of the XZ attack, that's actually a really important thing to audit. So they've actually gone through and stripped all those out. Or who needs an operating system? Some of the early stage stuff in this has been ported to UEFI. There was some, I think it was stalled out for a while, but I saw some recent work on it. There's some bare metal bootstrapping type stuff where you're just basically, you start with some bytes and you load them. So really, I would like to say let's move beyond trust. I mean, if you don't need to trust something, it actually becomes more trustworthy. We can actually verify this stuff. With free and open source software, you have access to the source code, you have access to all the systems in order to build it. With reproducible builds, you can be fairly confident that the binaries you're producing are the result of turning that source code into something actually usable. And through bootstrapping and especially diverse double compilation, we can actually verify that we haven't been compromised somewhere along the way in the tool chain. And you need a lot of compile cycles to pull this all off. But it's kind of important. These are like fundamental security problems that have been lingering for decades. And so we've been working on them. And you can too. So if you want to get involved with the reproducible builds or the bootstrappable project also is a really good one. They kind of started at one of our little reproducible builds meetups at one point, and I was like, why are all these people talking about bootstrapping umpteenth versions of Java? And then the very next meetup, I was like, oh, they're working on solving the trusting trust problem. I get it. Okay, great. So yeah, these are some great things, and looks like I'm a little over time. I don't know.
You're fine.
I'm fine. Okay. So yeah, thanks for listening to me ramble. Do we have some time for some questions?
Time for questions, yes.
Yeah. All right. We'll start in the back.
So I'm familiar with a similar problem that is probably solved with reproducible builds.
Uh-huh.
If I make a one line of code change to my source,
Uh-huh.
and I want to benchmark the two source files.
Uh-huh.
I'll end up compiling two different binaries, but what if something changed, like the user who compiled the binary changes?
Right.
Now I end up with a different binary layout.
Right.
And that binary layout is, could be responsible for a 10% performance improvement.
Possibly.
I'm falsely attributing to this one line of code.
Yes. Yeah. So, the more reproducible you get, the less likely those unintended variations work their way in, and you can actually just compare the performances. You're fairly confident without the patch, I get the same thing twice, or 3 times, or 100 times, and with the patch, suddenly I've got some other variables, So yeah, it's really useful for isolating out the variables so that you don't have unintended consequences. So yeah, that would be a great application of reproducible builds. Like I said, a kernel developer I know uses it to help with his refactoring projects. How about you?
When you're starting over and trying to reproduce everything from X0, has somebody published a blockchain with expected hashes of all the steps so that you can not only rebuild it, but you can check your checksums against the blockchain?
I know that there have been things shared. I don't know that they've done a transparency log or anything like that for that in particular, but that would definitely be a useful application or a thing to add on top of it to gain additional trust. Yeah.
Yeah.
You reproducible guys must be terrible at this, because I've been reading about this for, I think, decades. I remember in the early days, there was, yeah.
Oh,
Guilty?
I have a hunch I know where this is going, but go, continue.
I think what I read was that linkers had a bad habit of just like, I feel like reorganizing the segments in this crazy order instead today.
Yeah.
For no reason than just YOLO like randomness.
Yeah.
Has that been gone for a long time? I remember, I think it might have been GNU LD, and it's like Gold fixed it or something like that.
Yeah, there were some of those things. There are some newer things like profile-guided optimization, which are starting to reintroduce the same. Now that they fixed them, they're starting to worsen them again in the name of performance this time, rather than just doing it randomly.
Just YOLO fun,
Yeah. So there are some challenging things. There are occasionally like challenges like sometimes people will want to have like signatures embedded in the binaries, which makes it hard to then just do a checksum because, well, if you have access to the signing key, then the signing key isn't very useful. But if you don't have access to the signing key, you can't produce the exact same binary. So there are a lot of things that creep in like that. And it's just a matter of like working with upstreams, trying to submit all our patches upstream, and making sure they understand the issues. They don't always. Sometimes we come to a compromise, like the source date epoch thing is like a huge compromise, but also it like enabled us to almost instantly go from like 20% reproducible up into the 80% realm.
But specifically about the linker,
Yeah.
is that just like, oh, we need to tell these guys not to do it and to keep their story straight and be deterministic?
Yeah.
Is that like something we fixed a long time ago, thank goodness?
The linker is used in a huge part of Debian, and we're making that mostly reproducible. So in that sense, I think the worst of it is gone. There are some new things probably that have
Was there
creeped in.
ever any reason for it, or is it just like, it's just what happened?
This I don't know. Yeah.
Okay.
Yeah.
Okay, fair enough.
In the very back.
I have a, I don't know, partially formed idea. Is there any way that you could do like a surgical hash or checksum where you just cut out the bits where the signature is, or something like that?
Yeah.
And you have some kind of way to know what parts of the binary you're
Right.
sending, or like hashing or whatever.
Yeah, this kind of stuff is done. Like I know like our Red Hat packages, RPMs, do have embedded signatures in them, and so you kind of have to do this. In the strictest definition of reproducible builds, well, then they'll never be reproducible. We have also seen scenarios where people have these things that strip out the the stuff that's impossible to make reproducible, and then get overly aggressive and actually strip out meaningful stuff, and then you're comparing it, but you're not actually comparing the. So it dramatically increases the complexity between just checksum, verified or not verified. So it's ideal that to make it as mechanistic as possible to really stick to having it just be purely checksum based without any pre-processing. Bugs happen in the preprocessor at that point. And it's the same thing with, I think, Android packages, like the F-Droid project actually, does the same kind of thing, and they'll actually build the package independently as compared to the one released by Google Play Store or whatever, and then apply the developer signature on top of it, and then if the signature still checks, obviously you've got a really good build. Doesn't always work that way because not everything is so reproducible, but yeah, it is an option to be used sparingly and with great caution. But yeah, how about you?
Do you know of any examples of where people have corrupted the compiler and actually exploited something?
There's one example I know of. There were a bunch of malicious Apple toolchain compilers. It was a project called Xcode Ghost or whatever, and it was actually hinted at in some of the Snowden papers, and then people actually found like 4,000 some apps on the Apple App Store were compromised with it. because they charge a huge price for their developer tool stack, and so a bunch of Chinese developers released a compromised version of that entire tool chain and for free. And so people are like, well, I'll get the free one, of course. And yeah, so there are real world examples. That goes back pretty far. I think that was 2013, 2014, if I remember correctly. But yeah, in the Snowden papers, it's clear that there are powerful forces at work doing exactly that. So we need ways so that we don't have to be paranoid on that level. We can just verify our shit. I don't know. Yeah.
Speaking in reference to sort of bootstrapping all of the pieces necessary to sort of build a full system. Rob Landley, who used to be a maintainer of BusyBox, kind of got on this kick of like, what is the smallest possible Linux system that I can use? Okay, so you see where I'm going with this. So folks taking a look at BusyBox, or I guess now Toybox.
Yeah, I know there have been a handful of projects that have done things like that, like the super minimalist system, because the smaller the system, the easier it is to make reproducible. In Debian, we've managed to get 96% of tens of thousands of source packages reproducible, but open embedded folks, which are working on a much smaller set of packages, some of them have pulled off 100% reproducibility, and some embedded systems, those are great cases where you can narrow it down. But yeah, the smaller the system, the easier it is to make reproducible. I mean, that's almost by definition. So yeah, I don't know specifically anything targeting BusyBox or the Toybox or whatever, but certainly possible. All right, we all good? Any last questions? Yeah. So our website is reproducible-builds.org. So if you have more questions, you can find, we've got a mailing list. There's an IRC channel. They still exist. Yeah, and love to hear from you. See if we can help you out improving your best practices. So yeah, thanks so much.
5 minutes ago.
Alright.
I said I didn't really know what it was like.
Alright.
Thank you. You did a good job. I learned a couple things.
Cool. Yeah.
Both of them were about AI. Hell, it was down, okay?
Okay. Let's just call it a day. Alright. Cancel. I don't know. I'll just close this out.
Also, it could be a little polemic.
You get one step.
Alright.
The other one seems more. Nice bag.
Yeah, my
Alright. Oh, we should take the laptop, huh?
I think honestly I'm just gonna wander around.
Oh, yeah, don't leave your laptop. That would be bad.
Wander around the expo hall.
Okay, that's
I'm
going
serious
through, that's
on the
green
fence about
captains.
just buying one of
Captain
those.
support.
Hi, I'm Sunil from FreedomBox Project.
Oh, cool! I've been using FreedomBox recently.
I don't need it. Thanks for all the work you guys do.
But I can use it.
Thanks for the work you do.
Two AI topics.
Very cool.
We have FreedomBox pretty much
my,
fully reproducible, but not our
Bellingham.
images. I think
Oh, you
Right,
need
yeah.
some more work on that.
Yeah, file systems are hard.
They have one reference.
Oh, I get it.
Yeah.
You just wanna edit
But,
that.
very cool.
That's the pattern. You check out.
Yeah, I've had a couple bugs recently that were pretty ugly. But
Yeah.
I filed them and then they got fixed. And yada.
Yeah, the radical.
Yeah, the radical one is the new one that I haven't filed yet, but it sounds like you're aware.
Yeah, we already took care of that.
Oh, good.
Are you
Yeah.
using testing by any chance?
No, I stick with stable. Stable plus backports, I think, or
Oh,
you
yeah,
have it
yeah,
as
yeah,
the
yeah.
what is it called? The fresh releases or something.
Oh yes, yes, yes. We got a couple of issues there. Sorry
Yeah.
about that.
Yeah. No, I mean, for what you're accomplishing, it's just amazing. So yeah, I love it.
Felt your energy.
Right on. Yeah, where are you based out of?
I'm in Redmond right now.
Oh, okay. Yeah, I've definitely seen your name flying around on some of the various Debian stuff.
We chatted once or twice about boot issues related to
Oh yeah. I've been known to do that. I haven't been keeping up on U-boot lately. But yeah. But very cool. Yeah.
I think the only thing
Yeah, I just set it up. I tried FreedomBox like many years ago and just didn't have the energy to keep it running. I think the disk it was running on just died and I just never set it up again. But this time I set it up.